Hey everyone, welcome to linuxhint.com YouTube channel. My name is Talha and I'm here to teach you a Python course today. This Python course is for beginners and we're going to cover everything that you see on your screen here. So this is a complete outline for the course. If we talk about who this course is for, this course is for all those people who want to start their Python journey and they are the beginners and they want to understand the Python concepts. So a little bit I would talk about myself, that I have created this batch 3-hour scripting course which you guys really liked, and one of the comment talked about that you explain things like really clearly. So the reason behind that is I do not explain things that I do not understand. So if I'm teaching you something, which means I understand that concept very, very deeply and very, very well. That's why I'm teaching it to you. If I do not understand that thing, I will not teach it to you. I will not write any blog about it, or I will not even, record a video about it. So that is the one thing that you can be sure about. Okay. So this course is going to be exciting for those people who do not understand programming languages yet. Okay. That's a big statement. Why I'm saying that? Because I am going to start from the very, very basic and eventually, and I'm going to take you to the level where you can learn for yourself. All right. So without further ado, let's start. First of all, on the outline, we have introduction to Python. So what is Python? That's the question that comes to your mind. So the thing is that Python is a versatile and powerful programming language. All right. There is a thing between Python is a scripting language or programming language. I am going to answer that question right here. Okay. So in here, first of all, let's say Python is a versatile and powerful programming language that is used by millions of people around the globe. Whether you're a complete beginner or you have some coding experience, Python is a great language to learn. Why? Because it is the #1 programming language according to the programming index of the world, and it has a great future because you can build anything using Python, like website development, data analysis, machine learning, you name it, and you can use Python to do it, solving math problems. If you want to create games, if you want to analyze data, and as I've talked about, building websites. So you could do all of that with Python. One of the best things about Python is its simplicity. Why I say that? Because its syntax is very easy to read, which makes it perfect for beginners. While on the other side, if you see and if you talk about its flexibility, it is super flexible and it allows you to tackle a wide range of projects from simple scripts to very, very complex applications. All right. So in this course, of course, I'm going to teach you the basics. So we're going to start from our first program. We're going to talk about Python operators, if-else statements. We're going to talk about lists, tuples, sets, dictionaries, and we're going to talk about arrays all the way to a Python input. And then finally, I'm going to give you a detailed explanation on Python object-oriented programming. And I'm going to teach you all the concepts like encapsulation, inheritance, polymorphism. We're going to cover all of that. All right. So for now, we're done with the introduction to Python. So let's just highlight it because we are done with it. Now let's move forward. What you will learn this course that I also have explained to you guys, right? So we are done with that as well. So the important question, is Python a scripting language or programming language? So this is super important for you to learn. And why is that? Because if you talk about the programming languages, every programming language like Java, C++, essentially they are programming languages, but they are not scripting language. All right. A scripting language and a programming language are both tools which are used to communicate instructions to computers, right? But they have some differences, all right? If we talk about the Java and C, C++, these are programming languages, and they basically are used to create a wide variety of softwares, apps, video games, you name it. But if we talk about scripting languages like JavaScript or Bash, it is a more specialized and focused way of automating specific tasks and processes. All right. So they are like, having a smaller but more efficient set of tools for specific jobs. But if we talk about the programming languages like Java, C, C++, they are like having a big toolbox with many different tools, and each tool is basically serving a specific purpose. All right. So now let's move to the question that we had: is Python a scripting language or a programming language? So Python can be considered both a scripting language and a programming language. It really depends on how you use it. So as a scripting language, Python is often used to write scripts to automate tasks such as system administration, data manipulation, or web scraping, right? As I've explained to you how scripting languages work, that's the same thing Python is doing as a scripting language. But it can also be a programming language, right? Python is also a full-fledged programming language. Apart from being a scripting language, it is also a programming language, and it is capable of building large-scale software applications, including web applications, desktop GUIs, scientific simulations, and more. It can be used in machine learning. It can be used to generate AI applications, to create AI applications. Python is a very versatile programming language. So now let's move on to our next topic, which is how to install Python on Linux. So basically you can install Python on Linux if it isn't installed, but it comes pre-installed on Linux, on my Linux Ubuntu right here. So if I press Control plus Alt plus T, I would open up this terminal, and here I can basically write here Python 3 version, and here you can see that I already have it installed. So what if you do not have it installed on your Linux distribution? You can install it from your related package manager. For that, all you have to do is you write here sudo apt update, and you update your repository. And once you update it, after that, after updating, you can go ahead and write this command to install it. So right here, sudo apt install python 3. All right. So in my case, it is already installed. So that's why it is showing this. So in your case, if it is not installed, then you can basically write this command to install it. If you want to install a specific version of Python 3, in that case, like right now you can see we have 3.11, 3.11. So if you want to install, let's say 3.9, for that you would write here sudo apt install python 3.9. So I'm not gonna hit enter right now, because in this case it is going to install Python 3.9 version, but currently I have the latest version, so I don't want to downgrade right now. All right. So that's it from this topic. Now it is also done. So let's go ahead and let's run our first Python program. First write it and then run it. So the thing is that you can also install IDE, Python IDE like PyCharm on your system to run Python programs. But what I like to do is that I like to use any text editor like Nano or gedit, and then basically save those files as .py and then run those files with Python 3, all right, in the terminal. So that is the exact procedure that I'm gonna follow. You can follow along. So what I'm gonna do is that I'm going to open gedit first. So if you do not have gedit, you can install it. First of all, you can check here the version. This will basically tell you if you have gedit on your Ubuntu system or not. So if you don't have it, what you need to do is that you need to come here, update the repository first, and then you need to write here install gedit. Simple as that. So what this is going to do is that it is going to install gedit for you. In my case, it is already installed. So that's why it is giving this sort of thing here. So what I'm going to do is that I'm going to open up gedit right here from the terminal. So here you can see I have this untitled document. So all I'm going to do is that I'm going to write here print, and then I'm going to write here hello world. All right, so it's very simple to run Python script. You don't need to put any semicolon here because Python, like in Python, unlike other programming languages, the space and the cursor, when it goes to the next line, it basically ends the line. All right, so in other programming languages you have to like put a semicolon to end the line. So simple as that. So what we're gonna do is that we're gonna save it on some location. So I'm just gonna save it on the desktop, and I'm gonna save it like as hello.py. All right, so hello.py. So this .py, it would tell the interpreter that this is a Python script. All right, so what I'm gonna do is that I'm gonna save it on the desktop, and here you go. So we have hello.py saved. So there are now two methods to run this script. All right, either you make this file executable, and then you can simply just put // and then you will write hello.py and it would run it. What I like to do is that I like to write here Python 3 and then write the file name hello.py and run it. So right now we need to identify the location of the script, of the Python script that where we have saved it. All right, so for that what we're going to do is we are going to go to the desktop because I know I've saved it there. And what I'm going to do is I am going to ls here, so you can see that I have one file here, hello.py. So I'm just going to write here Python 3 and then I'm going to write here hello.py. So if I hit enter here, you can see that it is printing out hello world. So this is our first Python program that we have run it, and we have run it successfully. So now this is done, first Python program, and we have also run it successfully. So now let's move on to the next step, which is syntax and indentation. All right, so the thing is that syntax and indentation, they are fundamental concepts in Python programming, right? If we talk about syntax, a syntax refers to the rules and structure of the Python programming language, or any other programming language, basically, you can say. In the syntax, it includes elements like keywords, operators, identifiers, some literals, and punctuation. So a proper syntax is an absolute must in order for you to write correct and understandable Python scripts. So for example, in Python, to assign a value to a variable, you use the assignment operator or equal operator. So what I'm going to do is that I'm just going to the terminal here. I'm going to open up gedit. All right. So this is the equal operator that I am talking about. All right. So if you want to basically assign a variable to it like this, you could do so. Similarly, in order to define a function, you use the def or def keyword followed by the function name and parameters. All right, so I'm talking about the function syntax, which could be something like this. Def, like hello is the function name, and this would be the argument, and this colon will basically tell the interpreter that this is the function, and then you're gonna write here print hello. All right, and plus then I'm gonna write here name, which is basically the argument. All right, so let's say my name is Talha, and let's say if they are taking it by input or from wherever they are taking that argument, storing it in the variable named as name, and whenever they're gonna execute this function, this is gonna print out hello Talha. All right, Hope that makes sense. So if we talk about the indentation, it is the way Python defines the block structure and scope. So here you can see that after a colon, I put a space here and I wrote this statement right here. So this neat thing is indentation. All right. This is not indentation. So you need to understand that. Because in Python, Python is also indentation sensitive. So if you have wrong indentation of your code, this code is not going to run. So if you have it here, the indentation is wrong and your script or your program is not going to run. So you have to have the right indentation for your code. So indentation is mandatory and is used to define sort of blocks of code, in cases of loops, conditional statements, and function definitions, like I'm telling you right now with the function syntax right here. So that's it about syntax and indentation. So now let's move on to our next topic, which is variables and data types. Variables and data types, you can say that they are foundational concepts in Python programming. If we talk about specifically about variables, they are used to store data values in a program. So potentially you assign a value to these variables, all right, using the equal operator that I showed in the previous topic. Okay, so variables can store various types of data such as numbers, strings, list, dictionaries, and more. So for example, if you want to store a data, like if you want to store some data in a variable, you could do so. So I'm just gonna go to the terminal and I'm gonna open up like gedit, and here, let's say if I write here x equals 5, which means I am assigning a number to x. So x can be considered as a container that is getting the value 5. So wherever I would write x in my Python program, it would consider it as 5, not x, right? So ideally, you should know that this x is not actually x. Like computer is taking it as a 5 because x in itself is a container that is storing this value. All right, this value could be of any data type. It could be a float, it could be complex numbers, it could be a string even. All right, so here we have stored this thing. Now let's store another thing. Let's say we want to store a string. Okay, so we're just gonna write here, let's say Bob. All right, so now this is the variable called as name. It could be anything. You could name it like ABC or whatever you want, and here is the string. All right, so the string is being saved in this container which is called as name, and in other programming languages you need to specify the data type. Like here you would write integer in other programming languages, and here you would write string. All right, but here you don't need to write because Python itself identifies the interpreter, it identifies the data type, and then it assigns the data type to the variable. All right, so no worries about that. So if you want to create a list, that is also a variable. All right, so for that, let's say if I go here, if I create a list, or let's call it my list, and here if I just write here 1, 2, 3, all right, and if I just close this bracket, now I have created a list variable that is storing a list in it. All right, so now my list is a container which is not storing just one value, it is storing an entire list. So this list could be of any data type, like it could be numbers 1, 2, 3, it could be like a string of names like Bob, Ashley, and Talha, and this sort of list. So you can identify, you can tell that this is a list when you would have these sort of brackets in the beginning and in the end. All right. So we have talked about the variables. Now let's talk about the data types in detail. So as I was telling you that basically this is an integer, and if you want to have a float, float would be something like 3.15. This is float, and if you want to have another variable called as z, so if you do it like this, 2 plus 4j, now that is a complex number. All right, so this is like numeric data types. So you can say in numeric in Python you have 3 data types: integer, this one, float, this one, and complex, this one. So now let's talk about the next data type, which is string. So string can be enclosed in double quotes and single quotes as well. So like here, right, we have name variable. Now let's create a message variable and let's write in single quotes, hello Bob. All right, so both of them are strings. So you can, if you put double quotes and single quotes, it doesn't matter. All right, but if you do this like, you know, like this, it would be wrong. All right, it would give an error. So make sure like you have both quotations, quotation marks should be similar. So let's talk about the list now. So if we talk about list, list is a data type, and you can say that it is an ordered collection of items, and it doesn't have to be of the same data type. Essentially, it can be of different data types or same data types, right? So for example, if I write here like hello, and if I write here Bob, so you can see that list is containing, right now it is containing integer and string values. I could also do like this. So I hope you've got the point. You can have multiple data types within the list. So there is another data type called as tuple. So I'll just call it my tuple. All right, my tuple, basically it can have it is similar to list, you can say, like if I say it like this, 1 2 3, but the thing is that it cannot be changed. All right, it cannot be changed after its creation, while list can be modified. So now let's talk about another data type, which is tuple. All right, so tuple is like you know, similar to list, but the thing is that you cannot change it once you have created it. All right, in list, essentially you can make changes after the creation of it, and in here you cannot. So you can say that tuple is a static list and list is a dynamic list. So this is my these are my terms, okay? Do not quote me on that anywhere. This is static according to my concepts, and this is dynamic. You can call it that, but I don't know if there is any explanation or official terms that are being used for tuple and list like that. All right, so the next data type is dictionary. This is a collection of key and value pairs, which is like enclosed within curly braces. All right, so let's say this is dictionary variable, and let's say you want to have values in them. So you would have like name, put a column here. So once you put a column here, then you basically add the value of it. Like let's say I add my name, and then once you are done with it, then you separate another key and value pair with a comma. All right, so here you can see that this is the key and this is the value. So like you could say that in other cases here you were having like this was a variable and this was the value that you were storing in the variable. But in this case here you can see that in dictionary you can store like essentially name and value. So name is the key here and Talha is the value here. All right, so you can essentially identify the value with the key. Okay, so now let's move on here. Age, and then I'm gonna put in here age, so 28, and then I'm gonna put in here city, let's say. All right, and then I'm gonna put here colon. Okay, and then I'm gonna put up here, let's call it Dubai. All right, so that is dictionary. The next variable that we're going to talk about is Boolean. All right, so Boolean is something like this: true, either it is true or it is false. All right, so there can only be two results or two values for Boolean. Either it is true or false. So these are like 6 data types that we have discussed in Python. So like numeric, string, list, tuple, dictionary, and Boolean. So understanding these variables and data types are essential for you because you want to write Python code and you want to understand that. Okay, so these variables and these data types, they are involved in manipulating and processing different kinds of data. So you want to understand them really well so that you could have a good future with Python programming, and you have good concepts understanding so that you could really excel into this field. So now let's talk about the next topic, which is comments. So comments in Python, they are explanatory notes added to Python code to make it easier for humans to understand. So by humans, I mean the programmers. Like if you're writing a software or if you're writing a code and somebody else needs to make changes to it, they first need to understand the code and they need to understand why you have used what function there, or what what statement you have used there. All right. So for that, you need to write human explanation there for them to easily digest how you've written the code and make changes to them if needed. All right. So these comments, they are essentially ignored by Python interpreter, and they are purely and originally for the benefit of programmers. So in Python, you can create comments by using a hash symbol. Anything following the hash symbol on the line is considered a comment and it is not executed by the interpreter. So let me give you an example. I'll go to the terminal. All right, I'll open it up. I've just closed it accidentally. So I'm just gonna move to the desktop. Desktop. All right. So once I am here, what I'm going to do is that I'm going to open up my hello.py. So here you can see that I have added a comment. So if I do this, hash, this is a comment. So interpreter is going to come up and it's going to run this print statement, and it is simply going to ignore this comment because this is a comment is followed by hash. All right. So if I just simply save it, I go ahead and I run this Python program here. All right, so you can see that it says hello world. However, if I just do something like this, if I remove this hash from here and then I save it, and then I just go ahead and if I run this Python program here now, so what would happen? It would give me an error here that this is a comment, this is an invalid syntax. All right, so that is it. You can add multiple comments here, multiple stuff, multiple lines as well. So for example, if you want to add multiple lines on multiple comments on different lines, in that case you would use hash. All right. So what if you want to add a multiple line comment? Like let's say you want to add 100 line comment, let's say, for an argument's sake. So how would you do that? for that, of course, putting 100 hashes in every line is gonna be difficult. So for that, what you can do is that you can use triple quotes. All right. So let me show you that as well. So if I go here and let's say this is a comment, let's keep it that way. So I'm gonna use triple quotes like this, and whatever I would write inside of it is gonna be considered a comment, like all these lines. Multiple line comments, you can say that. So here you can see that now if I enclosed all of that in triple quotations, now this comment is closed, and now I can write another print statement here as well. Okay, so, or you can say done. All right, so what if I do not end this quotation? Then it would simply consider that as a comment as well. So I need to end this comment with triple quotes so that it knows, the interpreter knows that here the comments are ending. Otherwise, if you don't end that, it is just simply going to consider everything a comment until you close it with triple quotes. So these can be like this, single quotes, and you can also use like double quotes here. All right, something like that. So I hope this clarifies the concept. If I right now save it, and if I go here and I run my Python program here, so you can see that it is printing out those two print statements. So now let's talk about our next topic, which is Python operators. So we have like operators, which are like symbols that perform operations on variables and values. So I'm talking about symbols like plus, minus, subtraction, addition between those two variables. So I'm talking about symbols of that nature. So there are mainly like 5 types of operators in Python language or in Python programming. First type is arithmetic operators. Arithmetic operators are usually like plus, minus, these type of operators. Comparison operators, we have assignment operators, logical operators, and we have bitwise operators. Okay, so we're going to talk about each of them in detail. So first of all, let's talk about arithmetic operators. Arithmetic operators, they are basically used, I'm just gonna write here, in front of that. So first type is like arithmetic operators. Okay, so if we talk about arithmetic operators, they are used to perform mathematical operations like addition, subtraction, multiplication, division, etc. You can also find quotient, exponentiation. These type of things are also included under the umbrella of arithmetic operators. Okay, so let's go ahead and let's do a practical example for these to understand. So let's go ahead and let's open up the hello.py file that we are working with. So I'm just going to remove everything from here. So let's have 2 variables. One I'm going to call x, and I'm going to put a value here, and one I'm going to call y, and I'm also going to assign a value to y. All right, so now what I'm going to do is that I'm just simply going to print x plus y. So essentially what x plus y does is the addition to this thing. All right, so what I'm going to do is that I'm going to perform several operation here so that you could understand. So for example, if I have to do subtraction, I have to write here minus operator, and similarly if I have to do multiplication, I have to do something like this, steric, and if I have to do like division, then in that case I have to like write here this slash, and if I have to get the modulus or the remainder, then in that case I am going to use this symbol, which is a percentage symbol. All right, and in case I wanna get exponentiation x to the power of y, or essentially 10 to the power of 5, in that case what I'm going to do is I am going to put here double steric, all right, something like that. And then in case I want a floor division, or if I want a quotient, for that I am just simply going to put here double slash. Okay, so for I'm just gonna change the name or the comment like subtraction, all right, and here this thing is multiplication. I'm gonna quickly change it. So here you can see that these are all the arithmetic operators that we are using, and we are performing arithmetic operations essentially. So what I'm going to do is that I'm going to save it, and I'm going to go to my terminal, and I'm going to try to run it. All right, so here you can see that if I run it, it performs all those operations and it gives us these results. All right, so now let's move on to our next type of operators. These operators are called comparison operators. So in comparison operators, basically you're going to compare two values, and you're going to get a Boolean result. So for these same values, I am going to, like here, I'm going to open up the gedit again. All right, so if I open it up here, I'm just going to remove and get rid of these comments. So I'm going to use these two variables. So if I just type in here double equals, it means that it's going to check if x is equal to y, and it is going to return a result which is Boolean, true or false. Okay, so you can see that here we have double equal sign, and we know that x is not equal to y, so it's going to return false. All right, so then we have a not equal to operator, which you essentially write something like this. So we know that 10 and 5, they are not equal, so this is going to return a result which is going to be true. And then we have a greater than basically result. Okay, so greater than means that x is greater than y. All right, so we know that 10 is greater than 5, so it's going to return true. And then we have x is less than y. All right, so we know that 10 is not less than y, so it's going to return false. And then we have greater than equal to and less than equal to. So what we're going to do is that we're going to do something like this. So basically it's going to return true if x is greater than or equal to y. Okay, so remember that only one condition has to be true out of these two conditions in order for true to be printed. Okay, if both are false, then it would consider it as false. So similarly, we have less than equals to. Okay, you can write less than equal to something like this. So we don't need this statement, so we're just gonna comment it. So these are all comparison operators, and as I've told you, like these are equals to, not equals to, greater than, less than, greater, equal or greater than, and this is less than or equal to. So now let's go ahead and let's save it, and let's run our program here. Okay, so I'm just gonna end it. So I'm just gonna clear it. I'm gonna write here Python 3 hello.py. If I hit enter, you can see it is giving us an error here. So it is saying that this is the invalid syntax. All right, so I'm gonna have to take a look at it, that what wrong I have done here, and I know exactly what I have done wrong here. So I'm just gonna go here, and I'm just gonna go there. So instead of putting the equal sign here, I need to put the equal sign here. So make sure whatever you're writing like greater than or equal to, you're gonna put this greater than first, and then you're gonna put equal sign, otherwise it would give you an error. Okay, so I'll just save it, I'll go back, and I'll simply run the script. So here you can see false, true, true, false, true, false. Okay, so if you want to verify it, you could do so. Just open up the gedit. Okay, so here you can see, you can verify it side by side. All right, so here you can see that you have first statement, 10 is equal to 5, it should be false, and here you can see. Then we have not equal to 5, 10 is not equal to 5, which is true. Here you can see. Third is x is greater than y, which means 10 is greater than 5, which is true. Then we have x is less than y, 10 is less than 5, which is false. Then we have greater than or equals to. Okay, yes, this is true because 10 is greater than y or 5. And then we have false because 10 is not less than 5, it is not equal to 5. So both conditions are wrong, that is why it is printed false. So I hope you understand this concept clearly. So now let's move on to the next type of operators, which is like assignment operators. So these are the type of operators that are used to assign values to the variable. All right, so what I'm gonna do is I'm gonna get rid of all of that, or I'm just gonna comment them, let's say. Okay, so we comment everything here, and then we go here, and now we're gonna use assignment operators. So let's say we have x equals 10. All right, so what I'm gonna do is that I am just going to write here x plus equals 5. All right, so what this thing does, this first statement, basically that assigns the value to x. Okay, and then this thing basically adds plus 5 to x. Okay, so essentially you can say that this is equal to x equal x plus 5. All right, so which means that in the container x, or in the variable x, it is going to store 10 plus 5, which is essentially 15. All right, so if you want to verify it, you can simply print it and you will know it. All right, you will understand this concept. So now let's move forward. So let's say if you do it something like this, x minus equals to 5. All right, so that essentially means x equals to x minus 5. All right, so it is going to subtract 5 out of x, which is original value. Right now x is like 15, so it is going to subtract 5 out of 15, so it is going to give 10 value. So then we have another type of assignment operator, that is multiplication. So if we talk about the multiplication here, so let's make it like this, 5. So that essentially means the same thing, x steric 5. Okay, so let's try to do another thing, that is like division. And then finally I'm just gonna simply print out everything so that you could see what's happening. Okay, so I'm gonna print x on every step so that you could identify that what's going on here. So these are the things which are essential to understand when you are just starting out, because they are pretty basic, and you need to understand these things in order to understand the concept. All right, so let's just go ahead and in this video I will make some of the errors myself, essentially with the indentation and stuff, so that you could understand better that why these errors have shown up essentially, and how you can ignore them. All right, so this is the same thing like essentially if I just copy it and just change the symbol, so it's gonna work. Here you can see like this. So here you can see like this. Okay, so percentage. So next I can do the exponentiation with that as well, and I can also do the floor division. So I'm just gonna do that. All right. So for exponentiation, all I have to do is I have to put double static here. For floor division, all I have to do is I have to put double slashes here. Okay, it would essentially do the same thing. All right, so now we are done here, and if I want these to confirm everything that I have explained to you, all I would do is I would simply print X here. Okay, so I'm just gonna copy paste print every time. Okay, and I'm gonna explain it to you that why it is happening basically. So I don't need why. So here the thing is that interpreter would start to consider the program from here. It would start here. So first it would take the value X, which is equals to 10, and then it's gonna move forward to the next line, which is empty. Okay, you can keep it empty or you could just remove the space. It really doesn't matter. So then it would come to the next line, the second line. It would see that 5 has been added to the original value, which is essentially 10. So 10 plus 5 equals 15. So it is going to print out here 15. Then it's going to come here. So now originally X is 15 now, it's not 10. So if I remove these two lines, then or let's say essentially if I remove this line, then it would consider 10, and here it would take it as 10. But in between here you can see that we have used the assignment operator, so now the value would be different. Okay, so now 15 minus 5, it's gonna be 10, and now the X's value is 10. So 10 multiplied by 5, it's gonna be 50. It's gonna print out 50, and then it's gonna divide 50 with 5. All right, so the result is going to be 10. It's going to print out 10 again, and here you can see that we have taken the modulus, then exponentiation, and then floor division. So let's see what happens. So I'm just going to save it. I'm going to go here, and I'm going to run my Python script. All right, so here you can see that it has printed those values. So that's how the assignment operators, they do work. All right, so now let's move on to our next type of operators, which is like logical operators. So in case of logical operators, you can work with Boolean variables. All right, so Boolean variables are like essentially the true and false ones. So what I'm going to do is that I'm going to go here, open up the terminal, and then open up gedit. Let me remove all of that or get rid of it, and here essentially I'm gonna do true. Okay, and let's create another y variable, which I'm just gonna do false. Okay, so now I'm gonna perform logical operations in the print function so that you could see that how they are working. So and y, x and y. Okay, this is logical and. Okay, so both basically statements has to be true in order for it to work, or I could just simply write here and. Okay, then I'm just gonna print out here x or y. Okay, so this is a logical OR operation that's going to be performed, and then what I'm gonna do is I'm gonna have here not x. Okay, so this is logical not. So let's just save it, go ahead and run the program to see the results. So here I'm just gonna write here python 3 hello.py. So here you can see that it is giving us an error, and the reason behind that is that x or the variables, it has to be small x. Like Python is case sensitive, so if you write a small x and a capital X, they both are considered differently. All right, so for that, what I'm going to do is I'm going to go up here and I'm going to remove capital X and I'm going to put a small x, because essentially I have here small x. So if I would have here a capital X, then I need to put capital X everywhere. All right, so these are the errors that I was talking about. I would make those errors essentially intentionally. All right, so let's just save it and now go back and run our program. Here you can see we have false, true, false. All right, so logical operators are on the go. So now let's move on to the next type of operators, and it's the final type of operators that we have in Python. These are called bitwise operators. So these are the type of operators which are used to perform bitwise operations on integers. Okay, so these are the type of operators which are only going to be performed on integers. I'm going to give you an example for that. So I'm just going to open up gedit, and here I'm just simply going to put some random values, like, you know, y equals 3 and x equals, let's say, 5. Okay, so after that, what I'm going to do is I am going to write these operators, bitwise operators, inside the print statement so that you can understand them better. Okay, so I'm just going to quickly write. So now here you can see that I have done this thing. So one thing that I think I should mention here, that in the bitwise operators, this 5 is not actually going to be considered 5. It is going to be considered as zeros in terms of zeros and ones, okay, because that's the language that computers understand. So here I think for 5 we have the binary digits as 101 or 101, and for 3 essentially I think the digits are 0 or 11. Yes, so now the bitwise operations are essentially not going to be performed on this like 5 digit or 3 digits. This is going to be performed on like 101 and 011, and then it is going to produce the results accordingly. All right, so first we have bitwise AND, then we have bitwise OR, then we have bitwise XOR, we have bitwise NOT here, which is a tilde sign. All right, and then we have left shift, and then we have right shift. In the left shift, basically it shifts the bits to the left, okay, and then in the right shift it basically shifts the bits to the right. So in simple words, bitwise operators in Python, they are performing operations on the binary representations of the integers. So you need to remember that, because they manipulate individual bits within an integer rather than whole integer itself. So here in this case, like if you see that for AND it is going to set each bit to 1 if both corresponding bits are 1. So you can see 1 and 0, they are not corresponding. 0 and 1, they are not corresponding. And we have 1 and 1, which is corresponding. So it's going to turn this bit to 1 and the rest to 0. All right, so if we talk about the bitwise OR, so for this the result is going to be 1. So if we talk about the OR operators, so in case of OR, what it does, that it essentially sets each bit to 1 if one or both corresponding bits are 1. All right, so in that case the result here is going to be 7. And for the next operation, which is bitwise XOR symbol that you see, it sets each bit to 1 if only one of the corresponding bits is 1. Okay, so in that case the result is gonna be 6. And if we talk about this tilde here, or not operator, okay, bitwise not, bitwise, basically you could say in bitwise operation, this tilde inverts all the bits. So for example, if the bit is 1, it's gonna turn it to 0, and if the bit is 0, it's gonna turn it to 1. And so it's gonna give a result like, I think it's gonna give -5. Okay, so it's gonna give that result in 2 complements form. And then we have left shift. So what left shift does is that it shifts the bits to the left by a specified number of positions. All right, and then we have the right shift, which essentially shifts the bits to the right by a specified number of positions. For example, if I say here 2, it would shift the bits to like by the position like 2. All right, so I hope this makes sense. If you do not understand them, like for now, do not get confused, because as you grow, as you learn programming, you will understand them better. So you will use all of these operators somewhere in your coding. Okay, so it really depends what kind of project you're working on. You might want to understand this bitwise as well, because you might need to use them somewhere. So bitwise operators, they're primarily used in low-level programming, such as you can say device driver development. They're used in cryptography and network programming. They're also used in optimization techniques and some advanced algorithms. So if you need to do all of that, I would say pay attention to bitwise operators and understand them really well. After this video, you could basically learn more about them, or you could simply pause this video and go ahead and learn more about them. Okay, so these concepts that you would understand about bitwise operators, they are going to be super helpful when you're going to be working with performance optimization of the code as well. So now let's just save it and let's just go ahead and quickly view the results. So I'm just gonna right here this, and here you can see that these are the results that it has produced, and it has produced the exact results that I was talking about. All right, so now let's go ahead to our next topic. This is done. Alright, so now let's move forward and let's talk about if-else statements. The if-else statements in Python, it is used to control the flow of a program based on certain conditions. It allows you to execute different blocks of code depending on whether a condition evaluates to true or false. So what I'm going to do is that I'm going to show you the basic syntax of an if-else statement, and then I'm going to explain to you that what it means. Alright. So what I'm going to do is that I'm just going to go to the file here, and I'm just going to remove everything here, and I'm going to write simple basic syntax. So I write if condition, and then I write here code block. All right, so this code block could be consisted of like multiple lines as well, so it doesn't necessarily mean that it would be of one line. So first of all, you have if keyword here, and then you have the condition. The condition could be anything like variable A is greater than variable B or something like that. If that condition is true, only then and only then it is going to execute whatever is inside the body of the if condition, all right? Or if statement, you can say. So if, let's say, for some reason you do not have that condition as true, then in that case it is going to execute the else block, in which you would also have a certain code block. All right, so remember that indentation is case sensitive and you got to take care of the things. All right, so by this basic syntax you understand that how if and else condition works. All right, so what we're gonna do is that we are going to do an example to basically digest and to get this concept more clearly. We're gonna do a practical example. So let's go ahead and let's just simply define a variable here, x equals 10. And then what I'm gonna do is I'm going to put a condition here. If x is greater than 5, which of course it is, then in that case what I do want is that I want to print simply here that x is greater than 5. All right. So what I'm gonna do is that next in the else block, I'm just gonna print that x is not greater than 5. All right. So this will, these two print statements would basically tell us that which condition was met and what was printed out there. So for that, we'll just save it, and then I'll go to the terminal. And here in my terminal, I'm just simply going to run my program. And here you can see that it gives an error here, and we forgot to close this. All right. So you can see that it is going to give you these small errors if you miss something. All right. So as a beginner, these things are very important so that you understand and you never forget to double check your code. All right. So here you see that x is greater than 5. Why it has printed out x is greater than 5? The simple reason is that x's value is 10. So let's say if I change the value to 3 or 4, let's say to 3, and I save it, and this time if I run the program, you can see that it says x is not greater than 5. So what exactly happened here? So when the value was 10, so you know that x is a variable, it's a container. So here it compared 10 with 5. So this condition was true. So in that case, when the value was 10, it printed out this statement, x is greater than 5. So in this case, when we have x's value as 3, now it checked this condition, it was false, right? So 3 is not greater than 5. So in this case, it's just going to skip whatever you have inside this this block, in this if block. All right. So what it would do is that it would go to the else block and it would simply print out this statement right here. So now you can say, what if I want to have multiple statements or conditions, multiple conditions, and I want to check if those conditions are all met or one of that met, and I want to have multiple options. So in that case, you can use something called as elif in Python. Let me write here, it's written like this. All right, so let me make some changes. Let's do it 10 again, and this time I check if x is greater than 10. We know that x is not greater than 10, x is actually equals to 10, right? So let's see what would happen with that. So I'll keep this statement here, x is greater than, let's do it 10. And then I'm gonna have an else if statement, which means that if this condition is not met, it is going to check this condition that I will write here. Okay, so here I'm just gonna write x double equals 10. So which means that double equals just mean that equals to, if you remember the comparison operators that we studied, all right, previously. So in comparison operators, I showed you that this is equals to and this is not equal to, right? So we do this. So once we do that, we change this text to x is equal to 10. All right. So I'm just going to change this print statement, x is equal to 10. And then finally, I'm going to have another else if block. And here I can have as many else if blocks as I want. So that's what I just want to show you. All right. So here, let's say I just write simple else statement. So let's say you write here 10 else if statements according to your requirement of your project or program or whatever you're working on. So let's say you have written 10 else if blocks, and finally you just simply write an else condition here like this. Okay, so I don't need to write more else if blocks for this simple statement. So what I'm going to do is that I'm just going to add an else block. All right, so in this else block, what I'm going to do is, like, I have checked two conditions. So the final condition would be if that is met, then I know that it's gonna say that x is less than 10. All right, so these are only three possibilities with this. So we have x equals 10. It would check if 10 is greater than 10. Of course it's not, so it's just going to skip this block. Then it's going to come to the next block, and it's gonna check it. All right, if x is equal to 10, yes, it is true, so it's gonna print it, and it's going to skip that else block. So let's say if this value is, let's say 11, all right, or 12 or greater than 10, then this statement is gonna be true. It's gonna print this statement here, and it's just simply going to ignore these two statements. All right, so let's say if your x value is less than 10, it's 9, 8, or less than 8. So what's going to happen is that it's going to first, the interpreter is going to first check this condition. It's going to be a false, so it's going to jump into here, and it's going to check this. It's going to be false, so finally it's going to print out whatever you have in else block. You can have multiple statements in one block. It would consider it the part of the same block. All right, so let's say here you have 10 print statements in here. They would all be printed when this condition would be true. All right, so now let's move forward. Just save it and go here and run our program. So here you can see that it has printed x is equal to 10. So let's just check the theory and test the theory. Not the theory, actually it's a fact. So I save it, and then I just go here, and here you can see that it says x is less than 10. So if I just simply go here and I do it like 12, I save it, I run the program, here you can see x is greater than 10. So that was the if else block. Hope you have enjoyed it, you have understood it. So now let's move on to our next topic. So now let's jump on to our next topic, which is Python lists. So the thing is that in Python, a list is a versatile and mutable collection of items. Lists are ordered, meaning the item have a defined order, and you can access them by their index. All right, so each item in the list is assigned an index. It's kind of similar to array, but it's a little bit different because you can have multiple data types in the list. All right, so list can contain elements of different data types, including numbers, strings, and even it can contain other lists. All right, so here's I'm going to show you that how you can create a list here in Python. So what I'm going to do is that I'm just going to go here, and I'm going to remove all of that, and I'm going to create a list named as, let's say, my list. All right, so what I'm going to do is that I'm going to show you that how to create a list of integers, simple integers. All right, 1, 2, 3, 4, and 5. Okay, so this is a list of integers. So next what I'm going to do is I'm just going to simply show you that how to create a list with the sort of other data types. So like I'm just going to call it a list. So this is another list which would have multiple data types. So it could have Boolean, string, integer, float, complex numbers. So what I'm going to do is that I'm going to create a list here, and I'm just simply going to write here 1, which is an integer. Then I'm just going to write here a string, which is Steve, and then I'm going to write here true, which is Boolean, and then let's write a float number. All right, so here you can see that I have given multiple values of different data types. So first one is integer, then we have string, then we have Boolean, and then we have float. All right, so you can call it list with other data types, or you can call it like different with data types. All right, so now let's talk about how to access the values through the indexing. All right, so let's take this list and let's try to access the value by index. So the index starts from 0. Like this position is going to be on 0th index. This value is going to be on the first index, or index 1. This is going to be on index 2. This is going to be index 3, and this is going to be on index 4. So let's verify this information. So for that, I'm just going to write here print, and then I'm just simply going to write here brackets, and inside of that I'm going to write m_list, and then I'm going to have here 0. All right, so on the 0th index it has 1, right? So what I can do is that I'm just gonna simply copy and paste everything so that everything is clear. All right, let's just do 3 instead of doing all of them. So I do like this, 2, and let's do 4. So by this concept that I've explained to you, it should simply print 1, and then it should print 3, and then it should print 5. All right, so let's just save it and go ahead and run our program. So here I'm just gonna clear it. I'm just gonna go here, run the program, and here you can see that it has printed those values. So you can also use negative indexing in the list, okay, to access the element from the end of the list. So for example, if the last element would be -1 or -1. So let me talk about what I'm talking about. So here, this is going to be -1, this is going to be -2, this is going to be -3, this is going to be -4, and this is going to be -5. All right. So the thing is that it doesn't necessarily true for only for 5 item list. All right. Let's say if you have here 10 items, a collection of 10 items. So again, let's say the last number is 10, so that would be -1. So on -1 index, 10 would be printed out. Okay, so I hope that makes sense. So now let's try the negative indexing and let's verify what we are saying here. So what I'm going to do is that here I'm just going to say -1. Here I'm just going to say -2, and here I'm just going to say -4. So on -1 we have 5, on -2 we have 4, and on -4 we have 2. So let's just save it, go ahead and run the program. So here you can see that we have 5, 4, and 2. Okay, so this verifies our statement. Okay, so lists are mutable, meaning you can change the elements in a list. All right, so let's say if I want to change some value at a specific index, I could also do that. So what I'm going to do is I'm just simply going to remove all these print statements, and let's just say I want to change on the 0th index. So what I'm going to do is that I'm going to write here mlist equals, then here I'm going to keep mlist like this, and I'm going to change its value to 10. So now what I have essentially done, that I have replaced this value by using, of course, the index of the list. Okay, so now whenever I print this out, it should print out 10 instead of 1. All right, so what I'm going to do is I'm going to have a print statement here, just paste it, and I'm going to save it. Let's go ahead and let's run our program. Here you can see that now it has printed out 10. So similarly, you can check the entire list, like to verify if the value has actually changed. All right, so for that, if you want to print out the entire list, you could do so. Okay, so just save it, go ahead and run the program, and here you can see that the value has been changed successfully. All right, so you can also add elements into a list using methods like append, insert, or extend. So I'm going to show you all 3 methods on how to basically add an element to a certain list. So I'm going to add element to mlist. So for that, what I'm going to do is, first of all, I'm going to write here mlist, which is the variable name or the list name, and I'm going to write here append, and let's say I append a value 6. All right, so what it's going to do, that it's going to add 6 to the end of the list. So if I just simply go here and I print it, mlist, all right, if I save it and I go ahead and I basically run the program, here you can see that now 6 has been added. And why 1 has come back? Because I have removed the position or the index statement that I had here, in which we added the value or assigned the value as 10th at the 0th index. So right now we don't have any such value. That's why it would consider the original list, and I have appended this value at the end of the list successfully. So after append, what we're going to do is that we're going to discuss another function, which is insert. So in insert method, you basically specify the index and then you can change the value. All right, so for that, what I'm going to do is that I'm going to have here insert. All right, and then let's say I specify the index, which is 1. So 1 index means that it is going to replace this. Okay, so I put a comma here, and instead of 2 I do like 20. All right, so now it would print the list. So I'll just go ahead and save it, and I'll run the script, and here you can see that it has basically inserted the value at a specific index. So remember that in append it was adding at the end, and in insert it is adding on the index while it's not removing the previous value. All right, so you can see that here the previous value, it has just added another index at the end, and it has shifted all the values on the next indexes. So when you insert, it doesn't actually replace the value, rather it pushes it on the right side and insert the value on that specific index. So the next thing is extend. All right, so extend list, what it does, that it extends the list with the elements of another list. So for example, here I create another list. I'm just gonna name it another list. Let's say here another list. All right, so what I do here, that I have this list, say 7, 8, 9. All right, so now I have another list. So what I'm going to do is that I am going to extend the first list with the second list, or you can say that I'm going to merge them. All right, so what I would do here, I will simply go here, remove this, and instead of insert, what I'm going to do is I'm going to write here extend. All right, in the brackets or in the place of the argument, what I'm going to do is I'm going to write here an list. All right, so once I do that, I print out the list, and it would basically merge these two lists. All right, so let's just save it, and let's go ahead and let's try to run the code. So here you can see that it has now merged these two lists, or you can say that it has extended the first list. So I think I have explained the concept of lists in Python pretty clearly. So lists in Python offer a flexible and powerful way to work with collections of data. They're widely used in various programming tasks, and they are essential part of Python programming language. All right, so now we are done with the list. So now let's move on to our next topic, which is Python tuples. So Python like tuples are essentially the same as the lists, but there is like one difference. So in Python lists, you saw that lists were like mutable, which means that you can change, add, or modify the list. All right, or you can add the elements, or you can basically change or even remove the elements on a specific index. But in case of tuples, they are immutable, which means that once they are created, their elements cannot be changed, added, or removed. All right, so there is one way to do it, and that is basically if you want to add something at the end of the element of a tuple, you can simply concatenate it. Or if you remember the previous extend function we used, we can use a similar sort of thing in tuple, but it's not going to be a function. It's just simply you are adding a previous tuple into the new tuple. So I'm going to show you that how to do that as well. So everything that we've done in the list, we can pretty much do in the tuples. Just we cannot do the changes. All right, we can basically access the value on the index. We can basically create the tuple with the different data types. So let's just go ahead and let's just practically do it. So let's just name it my tuple. All right, and instead of these brackets, let's just put here parentheses. Okay, so now what is it? It is a tuple of integers. Okay, so simple is that. So what if you want to create a mixed tuple, or you want to create a tuple with multiple data types? So for that, let's just name it as other tuple, and just change the parentheses. So now we have a tuple with different data types. All right, so you see the similarity. So the only difference is that tuple is immutable and list is mutable, which means that you can add, delete, remove the items in the list, and you cannot do that in the tuple. All right, so now let's just move ahead and let's go ahead and let's print out the same values from indexes. All right, so I'm gonna go to my tuple. I'm just gonna name it my tuple here, and what I'm gonna do is that I want to print out the value at 0th index, which is going to be 1. Okay, so all I need to do is I need to save it, but let's just print another value to be sure that it's following the same thing. So instead of 0, I want to print the value at 3rd index. So 0, 1, 2, 3, which is number 3, but it's actually the 4th index. All right, so I'm just gonna write here 3. I'm gonna save it. I'm gonna go to the terminal, and let me just clear it, run the program, and here you can see that it has printed out 1 and 4, pretty much similar to the list. So the negative indexes, you know, they work the same way in tuples as they used to work in the list. So let's say if I do here -1, and if I do here -3, it's gonna print out 5, and it's gonna print out 3. All right, so I save it, I go here, you know, I run the code. Here you can see that 5 and 3, they are printed out. So since tuples are immutable, you cannot change their elements after creation. Okay, in lists you can do that. However, you can create a new tuple with modified elements or use tuple concatenation to combine tuples. All right, so I'm going to teach you how to do that. There is no specific function in Python to do it. This is like you can say that this is what you have to do yourself. All right, so you can see that we have a list here, so let's just call it another tuple. All right, so what I'm going to do is that I'm going to create a new tuple here, like let's just call it new tuple. All right, and let's just copy it and then remove it from here, like 7, 8, 9. So this is a new tuple, and now what I'm going to do is I'm just going to basically put underscore here so that it doesn't confuse itself, and then I'm gonna have here my tuple. All right, and then I'm gonna add a plus sign here, and then I'm just going to add the tuple like this. So what this would do, that it would add this tuple to already created tuple. So now the new tuple is gonna contain 1, 2, 3, 4, 5, and 7 and 8. All right, so that would be the output. So what I'm gonna do is I'm just gonna go here and I'm gonna print new underscore tuple. I'm just gonna remove this. So I will save it. I'll go ahead and I'll run the program, and here you can see that now it has concatenated the two tuples together. So we are done with Python tuples, and now let's go ahead and let's discuss the interesting topic of Python sets. But before we move to Python sets, you can say that where Python tuples are usually needed, okay? So tuples are commonly used when you want to store a fixed collection of items that should not be changed, such as coordinates, any settings, or database records. Basically, tuples provide a lightweight and efficient way to work with immutable sequences of data. All right. So now let's talk about sets. So set is an unordered collection of unique elements. Okay. Remember, when I say unique, I mean that sets are basically similar to the list and tuple, but they do not allow duplicate elements, and their elements are not ordered. All right. So sets are mutable, which means that you can add or remove elements after creation. So first of all, I'm going to show you how to create a set. So basically you just go here and let me just delete all of that. All right, so I'm just going to call it my set. All right, but here you're going to have curly braces. So now that's a set. All right. So this is a set of integers. So sets can also be created using the set constructor, but inside the constructor you need another argument, which can be a list or it can be a tuple. All right. So let's go ahead and let's see how we can do that. I'm just gonna call it a set or another set, and I'm just gonna write here the constructor set. And in here, I am just going to add a list from 1, 2, 3, 4, 5. So this is another way to create a set. This would create this set from 1, 2, 3, 4, 5, and it would add here to this variable. All right. So next, what I'm going to do is that I'm going to show you that sets can contain different elements of different data types. So for example, if I create here another or other set, all right, and I try to add different values like Steve here, basically I try to add the boolean and then I try to add a float. All right, so all of it can be done. So what if you want to add another value inside the set? You could do that. All right, so for that, what I'm going to do is I'm just simply going to write here my set, and then I'm going to write here dot add, and let's say I want to add 6. All right, so how do I know if that would be added or printed out here? All I'm going to do is I'm going to write here print, and then I'm going to write here my set. All right. So what this is going to do, that it is going to print out 1, 2, 3, 4, 5, and then it's going to print 6 as well, because I have added this 6 into the set. So let's just test it. Let's save it, go to the terminal, let's run the program, and here you can see that 1, 2, 3, 4, 5 and 6 have been added to the set. So let's just come back here, and next what I'm going to do is I'm going to also show you how to remove a specific element from a set using the remove method. All right, so for that, let's say we have added 6 and I just want to remove it. All right, so the thing is, notice here that it doesn't essentially take the index here, so it would take the value, the exact value that you would pick. So I have picked up here 6. So if I save it, go back here and run the program, here you can see that now 6 would be gone, but here you can see that it is giving us an error. The reason it has printed out the error because I just removed the add function. So I need to have this add function here because the value was like, you know, the value should be there. So pardon me for that. What I'm gonna do is I'm gonna have this here, and let's just remove something else. So now if I remove 6, it is going to be removed because it would be added inside of it. But let's just remove any other value. Let's just remove 2. All right, so I'm just gonna save it, and I'm just gonna go ahead and run the program, and here you can see 1 3 4 5 6. So that's the beauty of coding. When you encounter an error, you think, and thinking is your biggest capability, right? So when you face an error, just don't get yourself confused and do not worry. You can just simply go ahead and think about the problem and then think about a solution of that problem. This will teach you to solve other problems in life, which is really good. So let's move forward and let's perform another activity here. I have shown you how to add the element to the set and how to remove the element to the set. So now let's just do another thing, and I'm just gonna teach you how to work with the union, intersection, and a different set, and symmetric different sets with sets. All right. So if you have studied mathematics, you must be familiar with these terminologies that I am saying, where you study sets, and then you study the intersections of the sets and union and things of that nature. So let's just go ahead and let's just simply, create another set, okay, which we have created, but let's just change the values of these sets. So 3, let's start it from 6, 7, or let's just make a little bit changes. All right, so let's just go ahead and let's do the job here. So what I'm gonna do is that I have created these 2 sets, and now I'm just going to create a union set. All right, union set. So this is basically a variable, so I'm gonna use a built-in method. So first of all, I'm gonna write here m set, and then I'm gonna write here dot union. All right, and then I'm gonna write here a set. All right, which is another set. Or let's just, for the ease of understanding, I'm just gonna call it set 2. I'm just gonna call it set 1. All right, and for that I just need to go ahead and simply change these to set 2 and set 1, so that you understand better and in an easy way. All right, so these are those sets. So what I'm going to do is that now I'm going to print out the union set. So it would basically take the union of these 2 sets and it would print out. Okay, so I'll just write here union underscore set. I'm just gonna save it. I'm just gonna go ahead and going to the terminal, I'm just gonna clear it, and here you can see that we have basically a set, a union of the set is printed out. So you understand that union is like when you combine those 2 sets and you write everything here in an order. All right, so now let's just move forward and let's take the intersection of the set. So for that, all we have to do is let's just change the name of this set to intersection set, and set 1 dot intersection set 2. So that's what we're gonna do. So here we're gonna write intersection, and once we do that, I'm just going to simply print intersection set. So what it's gonna do is that it's going to take the intersection of the set and it's going to print out the values accordingly. So I'm just gonna save it. I'm just gonna go here and run the program, and here you can see that now it has taken the intersection of the set and only have printed out the common values that are common in these 2 sets. So you can verify here 3, 4, 5, they are the common values in these 2 sets. Okay, so now let's just move forward and let's discuss the difference set. So if you remember, you studied the math where you would basically, let's say you have set A and set B, where you would do just like set A minus set B. All right, So the difference set, it would take the difference of set 1 and set 2. So let's do it and let's see how it works. So I'm just going to call it difference set or diff set, and here I'm just going to write set 1 dot difference. Okay, and then I'm just going to simply change the variable name here, and I'm going to save it and go ahead and run the program. And here you can see that now it has taken the difference of the set and it has printed out the remaining values. So basically what it is doing, that it is basically doing it like set 1 minus set 2. So whatever common values set 1 has with set 2, it is going to eliminate all of those values, and it is only going to print out those values which are uncommon from set 1. So if we do like set 2 minus set 1, it is going to print out like 6 and 7. All right, hope that clears up the point. So the last example in the topic of set that I'm going to give to you is symmetric difference set. So let's see that what we get in symmetric difference set. So here what I'm going to do is let's just call it syn underscore diff set, which is of course a variable name. You can name it whatever you want, but here this is the function name, which is essentially case sensitive and you need to be accurate. All right, so what I'm going to do is that I'm going to write here symmetric difference. So symmetric underscore difference. So I hope I spelled it correctly, because if I didn't, it's gonna print out the error. So I'm just gonna name it sym, which is essentially the variable name. I just save it, I go ahead and I run it, and here you can see that it has printed out 1, 2, 6, 7. So in this case, it is not only printing out the uncommon values from set 1, but it is also printing out the uncommon values from set 2. All right, so that was the basic difference between the difference set and symmetric difference. All right, so I hope you now understand sets. You can say that where do I use these sets? All right, so sets basically they are useful when you need to store a collection of unique elements and you need to perform a set operations efficiently. All right, they provide a convenient way to work with mathematical sets and eliminate duplicates form of data collection. So you can say that whenever you are concerned with the duplication of the data in a set of data or in your data collections, you can be sure to use sets. So I remember that these guys, our teachers, our professors, these guys used to say that mathematics is the mother of all sciences, and I didn't understand it at the time, but as I advanced in computer science, I started to understand that maths is being used everywhere, especially if you want to work with machine learning, AI, boy, you need to learn maths. Okay, you need to be, I won't say you need to be a pro at mathematics, but you need to understand the basic concepts quite well. So I hope you are now start to learn these concepts, and I have explained these concepts clearly to you. All right, so now let's move on to our next topic, which is Python dictionaries. So in Python, a dictionary is a collection of key value pairs. All right, each key value pair in a dictionary, it maps the key to its corresponding value. All right, so dictionaries are basically unordered. They do not have any order. They are mutable, which means their values can be changed, modified, and it can contain elements of different data types. So there is no compulsion of having one single data type. So let me show you how to create a dictionary, and then let's go ahead and let's do some examples for that. All right, so I'm just going to remove everything out of here, and I'm just going to create my dictionary. This is a variable essentially, and then I'm going to put here equal sign, then I'm going to put here curly braces. I'm going to have to create a key here. So for that, I'm just going to create a key. Essentially, it's going to be name, and then I'm gonna have a name here, which is gonna be Bob, and then I'm gonna have the age of the Bob. All right, so I'm gonna create a key. The key would be age, and let's call it like 28 or 29 or 30. Okay, and then what I'm gonna do is I'm gonna put a comma, and let's say Bob lives in the city or in the New York. All right, so let's just write here New York. So you can see that we have two string data types and one integer data type here. All right, so you can have as many key value pairs as you want in the dictionary, but I'll just stop here right now for now. So you can see that here these are the three keys. All right, name, age, city, and these are the three values. All right, so the corresponding value of name is Bob. The corresponding value for the key age is 30, and for the corresponding value for the key city is New York. All right, so that is the basic syntax of creating a dictionary. You can also create a dictionary using the dict constructor or dict constructor with key value pairs. All right, so the way to do that, let me show that to you as well. So for that, let's just go ahead and let's create another dictionary, and here I'm going to use that constructor here. All right, so what I'm going to do is right now I'm going to pass the argument from here. So the argument is going to be, let's say, Jane, and then we're going to have the age of the Jane, which is going to be like, let's say 27, and then let's say we're going to have city, which can be, let's just say Los Angeles, like this. All right, so this is the city here. So this is how you create a dictionary like in another way. All right, with a constructor. So then dictionaries, you know, they can contain keys of different data types, including strings, integers, and even tuples. All right, so we can have mixed key types. So I'm just going to name this mixed dictionary, or like I'm just going to call it like that, mixed, dict, put it equal here. Then we have name, which is going to be, let's say name is Alice, and then we have 1 2 3, and it's a number, right? And then we're gonna have another key which can be a tuple, right? So let's just say 1 2, and then the value of it is gonna be tuple. All right, so here you can see that we have keys of different data types. So this key is string, this key is integer, and its value is string, and this key is a tuple and its value is string. All right, so I hope you got the point. This is also how you can create another dictionary, another type of dictionary. You can access the value associated with a specific key in a dictionary using square brackets. So let me show you that as well. So the first dictionary here that I've created, so let's try to access the value of name from my dictionary. So I'm just gonna print that. I'm gonna write here my underscore dict, and then I'm just gonna have square brackets, and inside those square brackets I'm just gonna mention the key, which is essentially name. So let me just mention another key. Let's just do it, and this time let's say I'm printing age. All right, so now name is the key and age is the key in my dict. All right, so name is Bob, age is 30, so that's what it should print out. So I'm just gonna save it. I'm going to go to the terminal, and here I am simply going to execute the script. All right, so here you can see that it has printed out Bob and 30, the two values of the relevant key. So you can also use the get method to access a value with a key, which allows you to provide a default value if the key does not exist. Okay, so let's just see how we can get the value with the get function. So for that, what I'm going to do is that I'm just simply going to remove this, and here I'm going to write dot get, which is a function essentially built-in. So here you're just going to write here, let's say city. So now it's going to get the value of the city, and city is the key, right? So let's say if the key does not exist, all right, let's say we have a key named as gender, all right. So what I'm going to do is that I'm just going to remove this, simply copy this and paste it right here. And let's say I write here a key which does not exist in the dictionary. So what's going to happen is that it's going to give an output none, and it's going to show that it doesn't exist. All right. So let's just save it. Let's go ahead and let's run the code here. You can see that for the first key, it gives the value New York, and then it gives none. So what if we add another key to the get function like this? So for example, we have gender, and then let's say we add a key, let's call it unknown. All right. So now what's going to happen if I save it, if I go ahead and if I run the code, here you can see that it gives the default value to the key, okay, unknown default value, which have been assigned. So let me explain to you what has happened here. So basically I tried searching the key here, and let's say if the key does not exist, what I have done is that I have assigned a default value. So what if I want to change this default value? You can do so. So let's just go ahead and let's just change it to the male, and let's just save it. Now the gender key does not exist, so it should print out this male default value. So I'm just going to go ahead and run the program, and here you can see that it has printed out the default value. All right, so let's see if we add the correct key here, which does exist, then what it does. Does it still give the default value, or does it fetch the actual value? So I don't know, let's just find out. So I'm just gonna put up the key here, which is name. I'm just gonna save it. So now here you can see that it has fetched the actual value, and it has ignored the default value. So if you do not have a default value, it's going to give you error, or the output, it's going to say that the key does not exist, which essentially means that there is no key. All right. But if you give a default value, and if the key does not exist, it is going to assign that default value to the key. All right. So let's just go ahead and let me tell you another concept, which is that you can add or update key value pairs in a dictionary using square brackets. All right. So let's just say that I want to add another, value, or I want to add a value to this. So what I'm going to do is that I'm going to have my dictionary, and I'm going to have the new value that I want to add to the list. So I'm going to write here, let's say gender, and then I'm just going to write here equals, and then I'm going to write here male. All right. So what it's going to do, that it's going to add a new key value pair in my dictionary here. Okay. So let's just verify that. So for that, I'm just gonna go ahead and I'm just gonna print my dictionary. All right. So I'm just gonna save it, go ahead to the terminal and run the script. So here you can see that it has added this gender key value pair here. All right. So similarly, as you have added a key value pair into the dictionary, you can also update the one you want. For example, if I want to update this here, which is age. All right. So the way to do that would be something similar. I would write here my dict, and I'm going to write here age, and then I'm just going to simply update it. All right. So I'll write here, let's say 35. So now if I save it, go ahead and try to run our script. Here you can see that now the age, this key value pair has been updated. Essentially the value of this key has been updated. So similarly, if you want to remove a key value pair from a dictionary using the pop method or del method, you can do that. All right. So basically to do that, to remove it, you have two methods. You can say pop and del. So if you are familiar with the machine programming, I'm not saying machine learning, but machine programming, you might have heard or studied this concept push and pop. So for machine language understanding, you need to understand the concept of push and pop. So it's kind of similar here, but it's not exactly the same concept. All right. So let's just go ahead and let's just try to do it. So what I'm going to do is I'm just going to go here and I am going to just simply, let's say if I want to remove the city. All right. So for that, all I have to do is that I'm going to write here my dictionary, and then I'm going to write here pop, and I'm going to write here the key, which is essentially city. All right. So what this will do, that it will delete the key value pair of city. So what I'm going to do is that we have the print statement. I'm just going to save it, and let's just go ahead and let's try to run the code, and let's see. Here you can see that now the city key that was previously present, now it has been deleted. It is nowhere to be found in the dictionary. So there is another method to do the same thing essentially, and that is like using the del keyword, all right, to remove a key from dictionary. So what I'm going to do is that I'm just simply going to write here del, and then I'm just simply going to delete let's say here my dictionary, and then I'm just gonna put square brackets here, and let's say I'm gonna delete gender, or let's say I delete the name. So now what this thing is gonna do, that it is going to delete name. So there are two ways, as I've told you. One is pop, and the other one is by using the del keyword. So I'm just going to save it, and now I'm going to see the output here. So I run the code, and here you can see that previously the name key was available with the value, but now it has been removed from the dictionary. So dictionaries, the basic examples, all those examples I have given to you. I hope you understood all the concepts. So the dictionaries are basically used, or you can say commonly used, for mapping between related pieces of information such as database records, configuration settings, or JSON data. Dictionaries, they provide a convenient and efficient way to store and manipulate data in Python. All right. So that's where you can use the dictionaries. So we are done with dictionaries, this topic. Okay, so now let's move on to our next topic, which is Python arrays. So basically arrays are similar to lists, but they are provided by the array module in Python standard library. So arrays are a collection of elements that are all of the same data type, unlike lists, which can contain elements of different data types. So if we talk about arrays in detail, basically they are more memory efficient compared to lists when working with large data sets of the same data type. So it is recommended to use arrays when you're using or dealing with the same data type. All right. If you're dealing with multiple data types within a list, then you can simply use lists in Python. All right. So let's just jump into it and let me show you how you can create an array in Python. Basically, you have to import the array module first. So for that, what you're gonna do is you're gonna have to remove here everything. On top, on the very top, you have to write import array. Okay. So what we would do that it would basically import the array module. All right. So next, in order to create an array, it's very simple and similar to the list. However, it differs slightly. So what I'm going to do is that I'm going to write here array dot array. Okay, so this is going to create a list of integers. All right. So what I'm going to do is that I'm just going to write here I. And I'm going to explain to you that what's happening in this line. So just bear with me for a minute. So here I'm just going to write here 1, 2, 3, let's say 4, and let's say 5. All right. So this would essentially create the array. However, in this example, this I, it specifies that the array will contain integers. You can specify different data types using the appropriate type codes. So for example, this I represents that this whole array is gonna be of type integer. If I do F here, it means that this entire array is gonna be of float data type. And if I do like D here, then this means that this entire array is going to be a double Persian floating point number. All right. So similar in a similar way, you can use for other data types. All right, for strings and for complex numbers and stuff like that. So you can access elements in an array using the indexing, which is quite similar to the list. So for example, I have my array. So what if I want to access what's on the 0th index? All right. So on the 0th index, what we have is we have 10. All right. Sorry, we have 1. All right. So what if I want to change that? So I'll change it later. First, let me just print it out and show that to you. So I'm just going to write here my underscore array, and I'm going to basically access the value on the 0th index. So as I have explained to you in the list, okay, in the list topic, this is the 0th index, this first one, and this is the index 1, index 2, index 3, and index 4. All right. So what I'm going to do is I am going to write here basically print my array, and then here I have written the 0th index. So next what I'm going to do is I'm just going to write here 2. All right. So the output is going to be 1 and 3 because 0, 1, 2, the index I'm talking about. So index goes like this: 0, 1, 2, 3, 4. So let's just save it and let's just test it. So let's just go here and let's just run the code, and here you can see 1 and 3. All right. So the next thing that we can do is that we can also modify the elements in an array using indexing and assignment. So let's say if I want to change something on the 0th index. All right. So I'm just simply going to copy it here, and let's say instead of 1, I want to have 8 here. So now on the 0th index, 8 would be assigned. So let me just comment it, and let me just print my array completely or entirely. So I'm just going to save it. Let's go ahead and let's run the code. And here you can see that entire array has been printed, and also I have replaced the first value or the 0th index with 8. All right. So that's how you can modify the value. Basically, arrays support all the standard list operations such as appending, inserting, removing, and even slicing. So let me show you that quickly. I'm just going to do a couple of things. here. So let's just go to the code here and let me just try to add something. Okay, so here I'm gonna write here my array. All right, and then I'm gonna write here dot append, and let's say I append 6. So what this would do, that it would append the value next to 6. And here we have assigned 8 to the 0th index, so it would print out 8. But if I remove this, then it's going to print out 1. So let's just remove it, or let's just comment it. So now it would not consider it. So now if I print my array, it should print out the values from 1 till 6. Okay, 6 would be added at the end. So I save it, go ahead, run the script or program, and here you can see that 6 have been appended successfully. So what if you want to insert something into array? So you could do that. So for that, you would just go here and you would write here my array dot insert. All right. Here you're gonna have two arguments. First, you're gonna mention the index, and then you're gonna change the value. So on the one index, what I want to do is that I want to replace 2, and basically not replace, but I'm going to add some value. Okay, so let's say I add 40. So what's going to happen is that it is going to insert 40 on the one index, which is essentially the place of this 2. And like list, it is going to push the rest of the values on the right side. All right. So let's just save it and let's see if it happens. So here you can see that instead of replacing 2, basically pushed these values to the right side, and on the one index it has inserted successfully this value. All right, here you can see the function that I used. So next, you can also remove any item on the index. So let's just say that if I want to remove some value on a specific index. So for that, all I have to do is write a remove function, and let's just remove, let's say 3. All right. So now 40 won't be there because we have essentially changed the function or removed the function. So now I'm using the remove function to remove a value on the index. So if I write here 3, it means 0, 1, 2, 3, 4 would be removed. All right, so I'm just gonna save it. I'm just gonna go ahead and I'm gonna print the value. So here you can see that 1, 2, 3, excuse me. So this is the thing here. So it is not taking as an index, it is removing the first occurrence of the element. All right, so this remove method, it doesn't take the index as the value to remove or anything that exists at the index. This is the actual value. So whatever the first occurrence of a number is, it would delete that. So for example, if I write here 1, it would remove 1. If I write here 5, it would remove the 5. All right. So let me just write here 5 and let's just save it. Let's go ahead and let's test it. So here you can see that the value or the element 5 has been removed. So what if I have 2 occurrences or 3 occurrences of the same number? So let's see what happens then, so that you can understand the concept very clearly. So let's say we have 4, 4, 4, or 3 4s. All right. So out of these 3, it is going to remove the first occurrence, this one. All right. So let me just randomize it so that you can understand this thing better. All right. So now let's just save it. And here, let's just remove 4. Save it again, go to here and just run the program. And here you can see that it has removed the first occurrence here, which was 4. Okay, the rest of the occurrences are there. So I hope you got the point. Next, let's quickly discuss slicing in the array. So basically you can slice the array to get elements from index 2 to 4. All right, that's what we're going to do essentially here in this example. All right, you can do it like to any index you want. You can do it from like 0 index to 3, 0 index to 4. It really depends on you. So what I'm going to do is that I'm going to slice the array to get elements from index 2 to index 4. So for that, what I'm going to do is that I'm going to have here my array, and I'm just simply going to write here brackets, and I'm just going to write here 2, and I'm going to write here 5. All right. So now what I'm going to have here, I'm going to have here sliced underscore array. Then I'm going to have here equals. So that's it. So here I am going to print out sliced array instead of my array. All right. So sliced underscore array. So let me explain that to you a little bit. So when you basically run this script, let's just run it and then I'll explain it to you. Let me just clear it for better view. So if I run the script here, you can see that now it prints out like 4, 3, and 4. All right. So here you can see that I have written like 2 till 5. So what happens is that here you can see 0, 1, 2. So here you have 4, here you have 3, and here you have 4. Okay, so these are 3 values. So let me just quickly write the value parallelly so that you understand it better, okay, for your understanding. So this is the 0th index, and this is the 1 index, this is the 2 index, this is the 3 index, this is the 4, this is the 5, and this is the 6th index. All right. So here you can see that we want values from 2 till 5. All right. So it will start to go from here, but it will go only till here. Okay. So 1 index less. So for example, if I write here 6, it would print out till here 4, 3, 4, 4. All right. So let's just do that and let's see what happens. So here I'm just going to run this, and here you can see that it's giving some indentation error. So I'm just going to go here and excuse me, this is the indentation error. All right. So let's just save it. Let's go ahead and run it. And here you can see that now we have 4, 3, 4, 4. All right. So I hope you got the concept of slicing an array. The last index that you put here, okay, here, this one, the array, the sliced array is going to start from here, from this index, which is here, and it's going to end on 1 less index that you would mention here. All right. So I hope you got the point. So if you were to ask me that why use arrays in Python, arrays basically they provide a memory efficient way, as I've explained to you earlier. They provide a memory efficient way to, let's say, work with the same type of data. So like if you have same type of data in data sets or in large data sets of numbers, then arrays can be very useful. However, for more flexibility and functionality, you would see that people prefer to use lists in Python. All right. So I hope you've understand this topic really well. So let's go ahead and let's move on to our next topic. This topic is done. All right, so now let's move on to our next topic, that is Python loops. So in Python, you have 2 kind of loops. One is for loop and another one is while loop. So basically loops, they are used to execute a block of code repeatedly as long as a certain condition is true. Python supports 2 types of loops, as I've told you earlier, like for loop and while loop. So if we talk about for loop, the for loop basically it is used when you know the number of iterations in advance, such as if you're iterating over elements in a list or performing a fixed number of repetitions. So let me go ahead and let me type some for loop syntax and let's do it. So here what I'm gonna do is, first of all, I'll create a list. I'll name it my list equals, and here let's say I have 1, 2, 3, 4, 5. All right. So then I run a for loop, and then I have element, which is a variable, and I'm gonna explain its function to you in a while. So I'm gonna write here my underscore list. All right, so once I have that, what I simply do here, I print element. So in this thing, it's gonna iterate over element in a list. Okay, so what does it even mean? So the thing is that here, this is my list, and these are 5 values that it has. Okay, so here in this for loop, this element is, you can say it is a variable whose value is not fixed. It's gonna change. All right, and it's gonna change according to the iteration number in the for loop. Okay, so in the first iteration, it's gonna go through the list and it's gonna pick up the first value, which is 1. It's gonna print it. Then in the next iteration, now element would have 2. All right, so it's gonna pick this up, print out here. Now in the third iteration, it would have 3 stored here. All right, so this could be any variable. It could be I, it could be a, it could be element. So I just named it element. So if I would do it like I, then I would have to change here I as well. All right, so hope that makes sense. So like if I save it and if I go to the terminal to run this thing, here you can see that it has like 1, 2, 3, 4, 5. All right, so next what I'm gonna do is let me show you that how you can use for loop in the range. So you can also iterate over a range of numbers. All right, so for that you have to use a specific method. So for example, if you say here for I in range, and let's say if you write here 5, so now it's gonna print out 5 elements starting from 0. So it starts from 0, 1, 2, 3, 4. Okay, it prints till 4. So whatever number you give here, it prints out one number less than that, and it starts the iteration from 0. So let me go ahead, save it, and let's just run it. All right, so if I run it here, you can see that it starts from 0 and it goes till 4. All right, so that was basic syntax of for loop. I'm gonna do an example of for loop in detail, but let's just move to while loop and let's understand while loop first, and then do an example in detail for both for loop and for while loop. All right, so while loops, if we talk about them, they're used when you want to execute a block of code repeatedly as long as the condition is true. So in while loop, you do not essentially know the number of iterations. In for loop, however, you know the number of iterations. Okay, so what I'm going to do is that I'm going to write here the simple syntax for while loop. So for that, let's just go ahead and here I'm just going to initialize a variable. Let's call it I equals 1. Then I'm going to write here while, and then I'm going to write here I less than equals to 5, and then let's write here print, and then let's write here I, and then I'm gonna write here I plus equals 1. All right, so this thing here is the increment. All right, it is going to increment I by 1 in each iteration. So let me explain to you the flow of this while loop. So first of all, you have the variable I. I has been assigned a value 1, and then you have a condition here with the while loop, which means that this loop is going to run until this condition becomes false. Okay, so 1 is less than equals to 5, which is true. It's going to go ahead and it's going to print 1. Okay, but after 1, you can see here it is going to increment this I. Okay, so I plus 1, meaning 1 plus 1 is 2, so it comes here. Now 2 is less than 5, yes, true. it prints 2, and then it goes here, increments it, then 3 is less than equals to 5, which is true. It prints this, then it increments this, it becomes 4, so on and so forth. So when it becomes 6, okay, this I becomes 6. Now 6 is less than equals to 5. No, that condition is false. So now this loop is gonna break automatically. So it will print from 1 to 5. So let's just go ahead, save it, and run the program, and let's see. Here you can see that it has printed out the values from 1 to 5. The reason being, it started from here, from 1. Let's say if I initialize 1 as 0. So what would happen, that it would print the values from 0 to 5. All right, so here you can see. The reason being is because when it would become 6, all the values would go false, or you can say this condition would go false, and it would break the loop, and it won't basically add up any value or increment it. All right, so let's just go ahead and let's do an example. So what I'm going to do is I'm going to do another example of for loop in which I'm going to have a list, and I'm going to use an else block, and I'm also going to tell you or talk about break and continue statements. All right, so break and continue statements and the else block you can use in both loops, for loop and while loop. So basically you can use these control flow statements. I'm talking about break and continue statements. They are called control flow statements. Okay, so break, it is used to exit the loop prematurely. So for example, if a loop is running and you come to a specific condition and you put a break here, it would prematurely exit the loop. All right, although it was not supposed to exit the loop, but with the break keyword you could do so. Then you have the continue keyword, which essentially what it does, that it skips the current iteration. So for example, you're on the second iteration and some condition gets true, and then you have the current keyword there. It's going to skip that iteration and it's going to jump over to the next. By skipping the iteration, I mean it is going to basically not execute whatever you have in the rest of the loop after you have the continue keyword. So we're going to do an example so that you can understand better. All right, so let's remove all that. Let's go ahead and let's have here my list equals 1 2 3 4 5, and then we have for loop. In here I'm gonna have for element in, and then I'm gonna have my list. All right, so after that I'm gonna have if element equals 3. Then what you need to do is that you need to break this loop, okay, or exit the loop when the element is 3. Else if, all right, else if, what I want you to do is I want you to have a condition here, else if the element equals 2. Then in that case, what I want you to do is that I want you to continue. All right, continue means that it would skip the iteration. So once it is here, after that, what I want to do is I want to print the element. All right, so I'll just simply write here print element. Okay, so now we are done till here. Now I want to have an else block here. Let's say if all the conditions are not met and the loop has run successfully, in that case, what I want to do is I want to print here, print. So let's say, what should I print here? Loop finished, let's say, without a break statement or without encountering a break statement. All right, so here we have a list. Then we have a for loop in which we are running the for loop through this list. All right, so what happens is that it performs iterations in a similar way. So when the value of the element is 1, it simply comes here, it checks it that this condition is false. So it skips it, comes here again and checks this. This is also false. So it prints this one. Okay, it will print 1. So when it becomes 2, the value becomes 2, it comes here, this condition is false, so it's gonna skip the body of the if statement. Then it goes to else if. Now the element is equal to 2, so this condition is true. So this continue would skip the iteration. So this thing is not gonna execute. It's gonna skip the iteration and it's gonna come back right here. Okay, so then what's gonna happen is that it is going to have another value 3, let's say. Okay, the element is gonna have 3, so now 3 equals 3. That is true. All right, so it's gonna break the loop and it's gonna come out of this entire for loops body, the cursor. All right, so after that we don't have any code, so it's not gonna execute anything. So it's gonna print out only 1 according to our dry run of the code. Okay, so let's save it, go ahead and run the code. And okay, so I just forgot to put colons here. Just remember that you need to add colons with if statements. All right, so let's just save it. Let's go ahead and let's run the code. And here you can see that it has printed out 1 only. And why it has printed out 1 only? Because of all that thing that I've told to you. So for example, if this thing is gonna be 5, or let's say 4, and this thing is gonna be 3. So now it's only gonna print out 1 and 2. And the reason is simple, because 1 and 2, they are not gonna be involved in any of that. So when the value becomes 3, it is false. However, this is true. So it's gonna skip the iteration, which means it won't print out this. So then the value becomes 4 and it basically breaks the loop. All right, so let's just go ahead and try it. And here you can see that it has only printed out 1 and 2. So what if I just simply go ahead and have some random values here which do not exist in the list, and hence they're not going to become elements. So I just write here 8, and let's say I just write here 9 or 10 or whatever, 44 let's say. So I just save it and I just go ahead. So now what's going to happen that this loop is going to execute perfectly. It's going to print out like 1, 2, 3, 4, 5. And these conditions are never going to become true. So it's going to also print out the else statement. Okay. So let's just save it. And then let's just go ahead and run the code. And here you can see that it has now printed out 1, 2, 3, 4, 5, and it says loop finished without encountering a break statement. All right, so I hope you got the point. So now what I'm going to do is that I'm going to give you an example of using an else block with a while loop. All right, so for that, what I'm going to do is that I'm going to initialize an I here, and then I'm going to have a while loop here. And let's just paste it. Okay, so here what I do have is, let me just remove this first. Okay, so here we have this print statement and we have the else block. So what it's gonna happen is that it is going to print values from 1 to 5, and it's also gonna print this, that loop finishes without encountering a break statement, because I do not have any break statement as of now here. So I just save it, I'll go ahead and I'll just print it, and here you can see 1, 2, 3, 4, 5. So in case I want to add a break statement, all I need to do is that I come here and let's say I add a break statement. I just save it, go ahead and let me just clear it, and I run the code. And here you can see that it prints out 1 and 2, because in the third iteration this becomes true and it breaks the loop. So I hope you got the point. That is it for loops. So let's move on to the next topic, that is Python functions. But before that, I want to add one thing to Python loops, which we studied. Basically, you can say that why loops are being used because you're a beginner. So the thing is that loops are being used in Python because you want to automate any repetitive task. If you want to do that, you have to use loops because you have to iterate over a large collection of data, and the only way to do that is like you have to use loops. So basically they are very essential for writing an efficient program in Python or in any other programming language. So you have, let's say, if you do not have loops in a programming language, you are going to have to write hundreds and thousands of lines of code. Okay, so that basically reduces the size of coding. I hope you got the point here, right? So now let's move on to Python functions and let's talk about them. So the thing is that Python function is essentially doing the same thing, like they are saving you lines of codes. So for example, like if you want to use a block of code over and over again, you don't have to write it or copy and paste it. You just create a function, and wherever you need that block of code, you just simply call that specific function. All right, so functions, they basically allow you to break down your code into smaller and more manageable pieces, you can say. So that makes it very easy to read, makes it very easy to debug and maintain. All right, so basically if we talk about specifically about Python, it provides built-in functions. It also provides you and gives you the ability to define your own custom functions. All right. So about built-in functions, you will understand once you understand the custom functions. So once you understand like how to call those functions and what is the background of it, you will very easily understand the thing about with the built-in functions, so that you will understand the argument thing and how you call it and how things are being returned in a function. So it would become very easy. So we're going to focus on custom functions. All right, so let me show you first the syntax of how to create a custom function. All right, so for that, what I'm going to do is that I'm going to come here. I'm just going to define a function. So def is the keyword that you're going to have to use to define a function. So I'm going to call this function hello, and I'm going to put a colon here, and I'm going to print something inside this function. So I'm going to call it hello world. All right, so simple is that. But if I save it and run it, nothing would happen. Okay, and why is that? Because it is a function. I have created a function, but I have never called it anywhere yet. So let me show you. If I save it, go ahead, run the code, nothing would happen because the code is correct. There is no error in the program, but I have never called this. So in order for this function to work, I have to call it. All right, so this is the def keyword that I have explained to you. You need to use it every time you want to define a function. All right, basically in this parenthesis you can pass arguments, all right, or parameters. But in this case here, you can see that function is taking no parameters. All right, so this colon, it indicates the beginning of the function code block, similar to if block and similar to loops. So here you can call the function. All right, if you want to call the function, you have to simply write the name of the function, and then you have to put down parentheses, something like that. So the output would be hello world because it would simply print out this. So let's go ahead and let's run the code, and here you can see hello world. So what if you need to call the function on multiple places in a single, program? All right, so if you need to call this function at multiple places, you could do that. So how would you do it? Like just simply call it again. All right, call it again. So what now it would do, it would call this function 4 times in this program. And if you save it, so here you can see that now I have saved it, and if I run the code, it basically prints it out 4 times. So if I want to call it like 8 times, here you could do that. All right, so save it, just clear it, and here you go. All right, so next thing that I want to talk about is how do you pass the parameters or arguments inside the function. So for that, let's say I want to create a function named as let's just edit this function. Okay, so what I'm gonna do is that inside here I'm gonna pass an argument called as name, and here instead of world what I'm gonna have is I'm gonna have a name. Okay, so for that what I'm gonna do is I'm just gonna go here, right here, the argument name plus, and at the end of the name I want an exclamation mark. All right, so here inside this hello I'm gonna pass an argument, so let's call it Bob. Okay, let's just save it, go ahead and run the code. It should say hello Bob, and if I change the name to John or something, it should say hello John. All right, so here you can see that I have basically made this thing dynamic now. All right, this argument, this is essentially a variable that is taking this value and then it is simply printing it out with hello. Okay, so you might have noticed in a few places where you log in, it says hello your name. So that's the basic thing behind that name display, your name display. Okay, so functions, they can also have return values. They can return value with a return statement. So let me go ahead and let me do a simple example. Let's create a function and I call that function add, all right, or addition. So what I want to do is that I want to have here 2 arguments. Okay, and what I want to do is that I want to add them. Okay, so what I do, I return x plus y. So what it essentially does is that it returns the sum of these 2 arguments. All right, so it doesn't matter what the arguments are, it is going to return the result. All right, so let's say if, for example, if I have here I have a variable equals, and then I call the method addition. All right, and let's say 3, 5. So now it's going to add 3 plus 5 and the result is going to be 8. So I want to display it, so for that I'll just write here print, and then I'm going to have here result. All right, so let's just save it, let's go ahead and let's run the code, and here you can see that we have 8. Okay, so here you can change the numbers to test it. 5 plus 5 would be 10. Okay, so another way to do that would be, let's say if you just want to have, you don't want to have a variable, you could also do that. Okay, print addition like this. Okay, so let's just save it, go ahead, run the code, it will give you the same value. All right, so it's basically 2 ways to do the same thing. So you can also have Python functions that can have default parameters values. All right, so the way to do that is that you have here, you have to create a function here. Let's just go ahead and let's create it. Let's call this hello, and let's have a name here, and let me have a default value for this argument, and let's just say it, let's just call it world. All right, so what I'm gonna do is now I'll print here hello, and then here I'm gonna have plus. Okay, all right, so here you can see that now we have name, but this is essentially it would have hello like world, it is a default value. So if you call a function without an argument, it's going to print this default value. If you give it an argument, it is going to print out that argument with hello. Okay, so in other cases where you won't have any default value in a function, if you don't give an argument, it's going to give you an error because it expects a value in place of the argument. Okay, so let's just go ahead and let's call the function hello. This should print out hello world, and let's call it another time, and let's have an argument here, hello Bob. Okay, so if I save it, here I go, I run the code, and okay, I need to put a colon here, I keep forgetting. Okay, so let's just save it, go ahead, run the code, and here you can see that it says hello world and it says hello Bob. And if I give a space here, then it would basically put a space there. Okay, so there you go, hello world because I called this, and hello Bob because I called this. Alright, so that's how you work with the default value in a function. So functions in Python, they are first class citizens, meaning they can be passed as arguments to other functions, returned from functions, and assigned to variables. All right, so let me show you what I'm talking about. So for example, if I go here, if I have a function called as, let's call it square, and let's have x here, and I want to return the square, which is going to be steric x. Okay, so once it is done, then I create another function which I'm gonna call cube. All right, it's gonna have an argument x, and I want to return cube. All right, steric x. Got it? So let's say after that, now what I can do is that basically I can pass these functions inside another function. So let's go ahead and let's write a function here. Let me call it apply function or something like that. And in fact, let me just call it function. Let me call this variable or an argument func, and then I'm gonna call here x. Okay. After that, I put a colon here, and inside this function I return func, and then I return x here. Okay, so now let's just go ahead and let's just work with the result. So let me call result1, and in here I apply this function, and as the first argument I pass this square function. All right, and then I pass this 3, and then in the result 2 I simply apply function, and here cube, and I pass 4 or 3. Okay, so after that, what I'm gonna do is that I have print here, and then I'm gonna have result1 here, and then I'm gonna have print here, and then I'm gonna have result2. All right, so for the first result, it's gonna give the square of 3, which is gonna be 9, and for the second result, it is gonna produce the cube of 3, which is like 27. So let's just go ahead, save it, and try to run it. Okay, so I need to put colon here. So save it, go ahead, run it, and here you can see that it has 9 for the square and it has 27 for the cube. All right, so these are the examples of functions. I hope you understand these examples and you understand the concept. Custom functions in Python, they provide a powerful way to organize and modularize your code. Okay, it makes it more readable, reusable, and maintainable. So I hope you got the point. So now we are done with functions. Alright, so now let's move on to our next topic, that is Python modules. So if we talk about modules, a module is a file containing Python code, typically containing functions, classes, and variables that can be imported and used into another Python script. All right. Modules, basically, they help you organize code into logical units, making it easier to manage and reuse functionality across different parts of your project. All right. So let me give you an example of modules. So first of all, let's go ahead and let's create a module. All right. So I'm going to go here, and here I'm going to create my module. So let me just comment this here, my module.py. All right. So what's going to happen is that I have to change the name of this file as well if I want to create this module here. So what I'm going to do is that I'm just simply going to create another file. So I'll just go to the terminal here, and here I'm just going to write here gedit my module.py. So this will essentially create another file which would be named as my module.py. So whatever I will write in this, this would be a module. Let's say if I write a function in it, it's going to be a module, and I can import that module into another file, like for example here in this file. Then by importing that module, I can use whatever codes, functions, classes I have in this file. I can use them here by calling the function, or by writing the module name dot function, and then of course giving the argument if that function has any argument. All right. So let's just go ahead and let's create this module. So I'm just going to comment it like my module.py. So now what I'm going to do is I'm going to create a function here, define hello. Then I'm going to write here name colon, and in this body I'm going to write print hello, and then here I'm going to write here plus, and then I'm going to write here exclamation mark. All right. So here we have this function. Now I'm going to create another function. Let's call it add. I have it here, and then I'm going to return x plus y. All right. So then I'm going to have pi equals 3.14159. This is basically the pi value. All right. So let's just save it. Let's just go ahead. And here, what I'm going to do is I'm just going to import this module. All right. So for that, I'll just use the import keyword, and then I'll write here my_module. All right. So once I do that, now I'm going to write here my_module dot hello, which is a function that we created there. And here I can just write here Bob. All right. So the thing is that you can see here that in this module we have this function named as hello. All right. So we are using this function from this module here into a totally different file. All right. So once I've done that, now what I'm going to do is the output of it is going to be hello Bob. All right, that we know. So now I can also go ahead and I can basically call my module here, and then I use the add function that I had there. All right. So if I could show you here we also had this add function. All right. So now let's just go ahead and let's just print it. Okay. So I'm just going to print result here, the variable that we just created. And then basically what I want to do is I want to get the value of this variable. Okay. So this is a simple variable named as pi, and it has this value. So I'll just go here, and in order to print it, all I need to do is I need to write here my module dot pi. All right. So what's going to happen is that it is going to work just fine. So let's just save it. Let's go to our terminal and let's try to run our script. Hello.py. So here you can see, okay, I again forgot to put colon somehow, so I keep forgetting. So pardon me for that. So I'll just save it. Go ahead, save it again, and let's just go ahead and run it. So here you can see that bingo, we got hello Bob, and then we've got this addition through the addition function, and then we've got the pi value here. So this is how a basic module works. Okay, you can also import specific functions, variables, or even classes from a module using the from keyword and of course import syntax. So let me show you how to do that. So for example, you want to import functions and variables. Specifically, I want to import, let's say I want to import this function, and let's say I want to import this variable. I don't want to use this like mymodule.add or mymodule.hello. I want to just call hello. All right. And I don't want to use this mymodule.pi. I just want to use pi. So for that, all you need to do is you need to root right here from keyword, which would get my module, and then you're going to import the function greet and variable pi. All right. So hold on, let me just delete this text from here. So hello Bob, and then okay, let me just remove that. So here now what's going to happen, now we have not written mymodule.hello and mymodule.py. Okay, let me just remove that as well. So now you'll get the results still. So this is another way to do the same thing. So just go ahead. Okay, and I run the script, and there you go. Import greet pi. Cannot import greet. Oh, excuse me. I just my function name is hello. I mistakenly wrote greet here, so let me just write here hello. Pardon me for that. So I'm some mistakes I'm making intentionally, and sometimes I just forget what I'm actually doing. So in both cases, I'm not going to remove these errors from this tutorial, so that you can get an idea that how many times while you're coding you'll get errors. All right, so let's just go ahead, and this is also learning. So we'll just run the Python 3 hello.py, and here you can see that we have hello Bob, and then we have the pi value. So this is another way to extract a specific class, function, or variable from a module. So Python also has a standard library of built-in modules that provide a wide range of functionality, such as math, random, OS, datetime, and a lot more other built-in modules. All right, you can import these modules and use their functions and classes in your scripts. All right. So there are two types of modules, all right, as I have explained to you guys earlier. One type of module is built-in, and another type of module is custom that you create. So we have now worked with custom modules that we created. So now we're going to work with the built-in functions, all right. Let's say I want to use a square root function, all right. So for that, what I'm going to do is I'm going to import. Now this import doesn't have to do anything with this module, all right. So let me just remove it completely, all right. So here I'm going to write math. So this math is a built-in module in Python programming language, all right. I haven't created it. You don't need to create it. It would be there, okay. So now let's say I want to use a function, math dot let's call it sqrt, square root, and then 16, and then we are done. So let's just save it and let's see what happens. I think for 16 we're gonna get like 4.0 or something. Yes. So that's what we have got. And if you remember, another way to do it is from math import sqrt, and then you can remove this math dot. All right, so let's just save it. Let's just go to the terminal, run it, and we'll still get the same result. So I hope this concept is clear to you. Now, this math doesn't have only square root function. It has many functions inside it, many classes. You can just, many variables. You could just basically go ahead and Google it and you will get to know. I'd recommend you practice a lot with this math module because we're gonna use it a lot in our third part of this course. Okay, this is the first part. We're gonna learn a lot in the third part, because we're going to use math function a lot when we are working with machine learning and AI. Okay, so if I were to summarize this, now you can also create your own modules by simply creating a new Python file in your project with that with an extension .py. So remember that you have to be in the same directory where you are creating this .py. If your file lies into another directory or in another project, you might need to give a complete path while you're importing this. All right, so you need to keep that in mind. So using module in Python, it allows you to organize your code, avoid duplication, and leverage existing libraries to add functionality to your own new projects efficiently. So you can use your old projects that you've worked on in the past, and you can work with their modules into your new project. So you don't have to write new code all the time. You can reuse your code basically this way. So that's it from this topic. Alright, so now let's move on to our next topic, that is exception handling in Python. So exception handling in Python basically allows you to gracefully handle errors or exceptions that occur during the execution of a program. So by handling these exceptions, you can prevent your program from crashing and provide helpful error messages to users and developers. So for example, if you are using your banking app or some similar app, and let's say you want to put in account number, right? So let's say you put some negative number, or let's say you put your name in there. Okay, so what would happen is that you would get an error message saying that you didn't put a number, okay, or it can only be a digit. So that's an example of exception handling. All right, so let me go ahead and let me give you an example on how you can basically use exception. So basically you need to remember that there are four keywords or four blocks, you can say, that you need to remember in exception handling. One is try, another one is except, one is else, and there is one block called as finally. All right, so let me just go ahead here and type here as well. So let me just remove this. So four blocks that I've talked about. One is try, the other one is except, the third one is else, and the fourth one is finally. All right, so now let's go ahead and let me give you an example and let's see what happens. So in this try block, I'm gonna put in the code that I want to execute. All right, so for example here I want to define a variable, or let's say, okay, x equals 10 divided by, let's say, 0. All right, so when I divide 10 by 0, or when I attempt to divide 10 by 0, it's going to create an exception. I want it to create an exception, and I want to produce an error saying that it cannot be divided by 0. All right, so I'm gonna name this exception something, 0 division not possible, or something like that. Okay, so, or you can say 0 division error. Okay, something like that. And then I am going to handle that specific exception by having an error here. So I'm just going to print and I'm going to say error cannot divide by 0. All right. So once I have this, what I'm going to do is that I am going to have another exception here. And why I'm having this exception, the reason behind that, if I don't know if there would be a specific kind of exception, or I don't know if there is any other kind of exception that could occur. All right. So one exception that I've created that is very obvious, that is that 0 cannot be divided, or any value cannot be divided by 0, according to this program, all right, that I'm writing. So what I can do is that I can also create another exception, staying careful, so that if user gives another input, or if your code is something like that, so that it can handle it, you could optimize your code so that it could handle any other type of exception being occurred. All right. So for that, what you're going to do is you're going to simply have a print statement here, and you are going to print what? An error occurred. Okay. So now what you're going to do is then you're going to come to the else block. All right. If the exception doesn't occur, or let's say these two type of exceptions don't occur, then what you're going to say is that you're going to print division successful. All right. So then finally you're going to have a finally block, and the thing is that this finally block is going to be executed regardless of whether an exception occurred or not. Okay, so even if the program running is successful, still it's going to print out. Even if there is an error, still it's going to print out. So this finally block is for the confirmation that the program has ended. All right, so there is no other type of problem in the device or any other thing. All right. So we'll just write here print, and then we're going to write here end of program. So now what I want to do is that I'll just save it. I'll go to the terminal and I'll try to run it. Okay. So when I run it here, you can see that it says end of program. All right. Here you can see it says 0 division error. Okay. And then it says during handling of the above exception, another exception occurred. All right, except 0 div error. Okay, so name is not defined. Did you mean 0 division error? All right, so what I'm gonna do is I'm just going to come here. So this 0 division error name has to be like this. Hold on, I just mistakenly wrote the name. So you can see the change of color here. So this is a specific exception in Python, you can say. So I'm just going to write here as well, code block to handle the specific exception. All right. And this exception is called 0 division error. All right. So the thing is that this 0 division error is called as the exception, which is a built-in exception available in Python. So I just named this exception wrong, which created another exception that you just saw there. So let's just save it, and now let's just go ahead and try to run our program. So here you can see that now the exception catching was successful. So it says error cannot divide by 0. All right, and then it says end of program. So let's say if I just say 10 divided by 2, and now let's just save it. Now of course it's not going to catch anything, and let's just see what happens next. So let's go to the terminal and run it, and here you can see that it says division successful, end of program. So what happened actually in both cases? So first of all, it tried to execute the block. So when the value was 0 here, of course, an exception occurred. It caught this exception and it printed this error cannot divide by 0. Okay, and then what happened that it printed this finally block by skipping this else block. All right, so you can say that this try except block is one block, and then this else block is a separate block. All right, and then this third finally block is a separate block. So this block is going to be executed all the times. All right, doesn't matter if this thing happens or doesn't happen, it is going to execute all the time. This block is only going to be executed if these two exceptions do not occur. All right, this try block is going to be executed first. Okay, or you can say that this try block is going to be executed all the time. Either these two blocks are going to be executed after the execution of try block, or this else block is going to be executed, and this finally block is going to be executed all the time. So I hope I made my point clear here. So if you want to use, or if you want to use the raise statement, or you want to raise a statement by a keyword specifically, you can do that. All you have to do is you have to use the raise keyword or raise statement to manually raise an exception. All right, so for that, what I want you to do is, let's just remove all of that, and here I'm going to define a negative variable. So I want to handle this exception of negative variable. All right, if x is less than 0, then in that case I want to raise an exception. Let me say it value error. This value error is also an exception, like 0 division error. All right, so you can see the change of the color here. Okay, so then I'm just gonna write here x cannot be negative. All right, so we know that x cannot be negative. We just want the positive value. It's something similar. You can imagine that somebody has created a calculator that only takes positive values. So he would need to raise this exception in case somebody puts in the negative value, so they would get this error. Okay, or let's say somebody has created a form in which their age is required and they put the age negative. All right, so then in that case it can be very good thing. Like for example, it can be age. All right, so age cannot be negative. All right, this exception is going to be very useful in that case. So now this would basically raise a value error exception. All right, with the custom error message that we have here. So let's just save it, go ahead and run the program. Let me just clear it from here. So when we run it here, you can see that it says value error x cannot be negative. All right, so I hope this basically clears your concepts, and now you understand how to handle exceptions in Python. All right, you could say that why we have to use exception handling, and the answer to that would be the one that I gave you at the beginning of this topic. All right, so exception handling in Python, it basically allows you to write robust and reliable code, and it can handle basically unexpected situations or errors. This basically helps improve the overall stability and usability of your programs. All right, so that's it from this topic. All right, so now let's move on to our next topic, that is Python math. In Python, the math module provides a wide range of mathematical functions for performing mathematical operations. So as we have discussed Python modules, we just discussed one example of Python math, but in here I'm going to explore it a little and discuss with you multiple functions. Of course not all of them, but I'm I'm gonna discuss like 4, 5, 6, or maybe 8, around 7, 8 functions, so that you get an idea and a little bit understanding of math function. So let's just go ahead and let's do it. But before that, I just want to tell you that you could use this module to perform various mathematical calculations, including trigonometric functions, logarithmic functions, exponential functions, and a lot more other. You can even work with infinity in this, and I'm just gonna share an example with you on that as well. So of course, if you want to use math module, you have to import math module into your project. So we'll just go here, and I'm just going to remove all of that. I'm going to write here import math, okay? And then the first function that I want to talk about is, of course, we have talked about square root function. Now I'm going to talk about factorial. So I'll just write here print, and here I'm just going to write here math.factorial, and then of course I want to take the factorial of 5, let's say. All right, I think the output of this would be 120. Okay, so what I'm going to do is that I'm going to write output here as well, so that when we run the code we could match the outputs. All right, so now what I'm going to do is that I'm just going to write here print, and then I'm going to write here math.sign, and then I'm going to write here math.pi, then let's divide it by 2. All right, so here you could see that we are using sign, all right, and we're calculating it, and let's see what the output is going to be. So I'm just going to write here no idea, and then let's go ahead and let's calculate cos or cosine. Okay, so for that I'm just going to write here math dot cos, and let's just keep it 0. All right, so for 0 I think it's gonna be 1, but not sure. So then what I'm gonna do is I'm gonna calculate logarithm base 10. All right, so I'm gonna just write here print math.log 10, and if you take the log of 100 with the base 10, then I think the output would be like 2.0. All right, so then I'm going to show you how to calculate exponential values with math. All right, so if you write here print math.exp, and you want to take an exponential value of 2, and then you want to write here print, and you want to write here math dot degrees, and then you're going to write here math.pi. all right, so now the output of this is going to be 180 because it has like 180 degrees. All right, so about this I think it's going to be in float or something, so let's just keep it like this, no idea. So then I'm going to talk about another function. Let's talk about radians. All right, so for that what I'm going to do is that I'm going to write here math.radians, and then I'm just going to write here 180. all right, so this will produce an output. I think it's going to produce something around 3.14, like the pi value, but I'm not sure. All right, so let's just keep it that way. So these are all the built-in functions that we have used. So how about the constants in math function? All right, so if we talk about constants, then we have math.pi, right? Of course, this is going to be math.pi is going to be 3.14159 or something like that. And then we have math.e, and that would be like around 2.7. So I'm just going to write here print math.e, and then I'm going to write here print now math.inf, which is infinity. All right. So this would be considered as positive infinity. You could also have negative infinity if you want. All right. So here, let's just type this. So now let's just go ahead and save it and try to run our code here. So let me just clear it. And here you can see that it's giving some sort of error here. So, okay, syntax, this was never closed. All right. So let's just go ahead and let me just close it with a bracket. I forgot to close it. So make sure that you follow the syntax. All right. So if you make a syntax mistake, it's going to point it out. So save it. Let's just go ahead and let's just run the code again. All right. So here are the outputs that we have. And here are the functions and constants that we have gone through. All right. So here you can see that for factorial 120, we've got 120. For math dot sign, and inside that math dot pi divided by 2, we've got 1.0. All right. And then we've got for cos 0, we've got 1.0. For log, yes, we've got 2.0. And for exponential, we got 7.389, so on and so forth. And then for math.degrees, we've got 180. Then for math.radians, the value is 180. We've got 3.1415. And then for pi, math.pi, we've got the same value. And then we've got math.e as 2.718, so on and so forth. And then for math.infinity, we've got positive infinity here. And then negative math.inf, we've got negative infinity here. All right. So I hope like you've got the point of using math function. So this is how you can use multiple functions and constants. So these are just a few examples of mathematical functions and constants available in math module. You can explore the full list of functions and constants provided by the math module in the Python documentation. All right. So what I'm going to do is that I'm going to put the Python documentation link in the description so that you could go there and you could check it out. And the math module, basically, you can say that it is a very powerful tool for performing complex mathematical computations in Python. All right. So we're done with the Python math. All right. So now let's move on to our next topic, that is string formatting. All right. So basically, string formatting, if you talk about it specifically, it allows you to create strings with placeholders that can be replaced by values dynamically. Okay, so there are, you could say, like several ways to format strings in Python, in which you could basically have mainly three type of methods. All right, one, you can do that by using percentage operator. Another method is by using string.format method, and the third is by using f strings or using formatted string literals. All right, so I'm gonna go through each one of them. So let's just start, and first of all I'm gonna discuss the percentage operator. So what I'm gonna do is I'm just going to go here. Hold on, let me remove all of that. And first I'm going to discuss the percentage operator. This is also called as old style formatting. So in it, hold on, let me just write here the variable. Let me call it Bob. And then I have an age equals, let's say 26. So what I'm going to do is that I'm going to print here, and I'm going to use this percentage operator here in this print statement. So I'll just write here hello, and then I'm going to write here percentage s. Okay, if you have worked with C, You would be familiar with that. I'm just gonna explain it to you in a while. So you write here %d years old. Okay. So here you need to have this quotation. Okay. So something like that. So once you are done with that, you need to basically have those variables here, which is a way for this print statement to know that these are the values that you need to print. So in C programming, if you remember, for strings you used to use %s, and for integer you used to use %d. If you're familiar with C programming and if you've done C programming, you would know that. So this is an old style to format strings, and this still exists in Python. All right. So another thing, of course, you need to mention the variable name so that it could assign this specific string and this specific integer. So for that, what you're gonna do is you're gonna put a % here, and here you're gonna mention name variable, and then you're gonna mention age. So what would happen is that it would pick up the name string from here, and it will print it here, and it would print out the age. It would pick it up from here, and it would print out here. So let's just save it, and let's go ahead and let's test it. Let me just clear it, and here if I run the code, you can see that it says, hello Bob, you are 26 years old. So that's one type of string formatting. So if we talk about another type of string formatting, you could also do that. So let me just go ahead and let's call it str.format. all right. This is basically the string formatting method. All right. So I'm just simply going to use, hold on, let me just use the same code that we have. Let me just go like this. We have name, and then we have strings, and inside the print statement I'm gonna say hello, and then I'm gonna use brackets. Okay. And then I'm gonna say you are brackets years old. All right. So this is how this string.format method works. So, and in the end here, finally, I'm just gonna write here dot format, and then here I'm gonna have values name, age. Okay. So in this case with dot format, you're gonna have to put brackets, these curly braces here. It would consider this curly braces as this first value that you've given here, and for the second bracket it is going to consider this second argument that you have given here. So let's say if you put age here and you put name there, then it's going to print out age first, and then it is going to print out name. So let's just save it. Let's go ahead and try to run it. Here you can see that it says, hello Bob, you are 26 years old. And let's just test that as well that I just explained to you. So I say age, and then I say name. So let's just save it. Let's go ahead and let's see what happens. And here you can see that it has done exactly that what I have explained to you. All right. So now what I'm going to do is I'm going to discuss the third and final method in strings. Basically, there are three methods as I've told to you. There are other formatting options as well that I'll discuss after that. For now, let's just go to the third method. That is like using f strings, and these f strings means that you're using formatted string literals. All right. So now what I'm gonna do is I'm just gonna name here something, age, that we have. Now I'm gonna use f literals, so I just write here f, and then we say hello, and here I'm gonna write name. Okay, and here I'm gonna simply write age. Okay, so by just writing f here, this should work. All right, and I should remove this. So this name here, this is this variable. Like you can see the variable name is name, and this age here, this is this variable. So it's gonna print out hello Bob, you're 26 years old, the same thing. All right, so here you can see. So all three methods basically achieve the same result, but F strings, they provide a more concise and readable way to format strings in Python, and they are like simply very easy to do thing. All right, you can also specify formatting options such as padding, alignment, and precision, and data type conversion. So now let's talk about that. And about F strings, they were very nice way to format strings, and they were introduced in Python 3.6 and later versions. All right, so if you're using any other version like Python 2.9, probably this F string thing is not gonna work. All right, so let's go ahead towards the formatting options, and let me write an example for that, and I'll explain to you that like what it is doing. All right, so first of all, I'm gonna have pi variable. Let's give it a value 3.14159 as far as I can remember. Okay, so then what I'm gonna do is I'm gonna write here print, and I'm gonna write here the value of pi is approximately, and then I'm gonna format it. All right, I'm gonna explain to you what exactly this thing is doing, so just bear with me for a second once I'm done writing all that. All right, so I'm just gonna write here dot format, and of course I'm formatting this. So after formatting it, the approximate value it's gonna give is like 3.14. okay, but I'm gonna explain to you what this thing does. So let's just go ahead and let's have now something like price is equal to 99.99, and let's say I want to format it in the same way till like 2 digits. All right, so for that, what I'm gonna do is I'm gonna write here print, and then I'm gonna write here the price is, and I'm gonna write here dollar, and then I'm gonna write here brackets like dot 2f, and then I'm gonna write here format, and then I'm gonna write here price. All right, so then after that, I'm just gonna put up some number here. Let's say 1 2 3 4 5, and then I'm gonna print here print. All right, so I'm gonna say padded number, and then I'm gonna say something like this, colon 08D, and after that, what I'm gonna do is I'm gonna write here dot format, and I'm gonna write here number. Okay, so once I'm done with that, one final example I want to do is with percentage. Okay, so if we talk about percentage, we can also format it. Let's go ahead, let's have a percentage variable name, and let's say we have it like 0.75, and then we want to print percentage, and then we format it in the same way, colon 0.2 percentage. All right, so I'm gonna first show you the output, and then I'm going to explain to you that what is actually happening here. So write here dot format, and inside format you just write here percentage. Okay, and remember to close the bracket like this. So once you have that, now let's just go ahead and let's just save it, and let's run the program to see the output. So here you can see that it has formatted the value up to 2 characters. after point, right? 3.14. So here, because of this formatting, here you can see. All right. So now for the price, we had the same formatting, so it has kept it there. It was already here. So if I have it here like 9.9999, something like that, it's gonna format it accordingly. So then we had the number. It has formatted it in this way. And then we have the percentage that it has formatted in this way, 75%, because of this. So now let me explain to you what this thing is. All right. So this is simply a notation, and these are kind of similar expressions which are used for formatting strings in Python. All right. So if we break them down, these curly braces that you see here, okay, this marks as a placeholder in the string where values will be inserted. All right. So then if we talk about the colon here, this one, okay, this basically separates the placeholder from the formatting instructions, this colon right here, okay. And then you have point 2, which basically specifies the precision of the formatting. In this case, point 2, it indicates that the value should be formatted with 2 decimal places. All right. And then we have F, which indicates that the value should be formatted as a floating point number. All right. So this is exactly the same. So again, these are the brackets, which are like placeholders. This column separates the placeholders from the value. This point 2 tells you that the formatted value should be like having 2 decimal places, and then this is like the data type, which is float. All right. So then of course you have this format price, which actually gets the value and formats it according to this notation. All right. So this whole thing, if I were to summarize it, it means that the value inserted into this placeholder will be formatted as a floating point number with 2 decimal places. I hope this thing is clear now. So let's come to this point. D stands for integer data type. All right. This colon stands for the same thing, like it's a placeholder, and this colon is a separation between the placeholder and the actual value that you're going to insert. All right. So the thing is that this formats like this whole thing, it formats an integer with 0 padding and a width of 8 characters. So we know we only had 5 characters, so it has added like 3 more characters to match this. Okay. So then if we talk about this percentage, all right, the whole thing is going to be the same. The brackets as a placeholder, the colon is going to be the separation between placeholder and the value inside. Basically this thing, it formats a floating point number as a percentage with 2 decimal places. All right, this 0.2 for 2 decimal places. All right, and this percentage specifically formats a floating point number as a percentage. All right. So these formatting options that we discussed, they allow you to control the appearance of the inserted values in the string. Like you can control the appearance of number of decimal places, padding, alignment, and data type conversion. All right. So now that's it in the matter of string formatting. I hope you've learned a lot in this topic. Basically, string formatting is very, very flexible and powerful. It allows you to create formatted strings that can be modified according to your specific requirements. All right. So you can choose the formatting method that suits you the best, but I have explained to you all the possible methods, or at least you could say the basics of them. Now you could go ahead and use them into your advanced programming skills, and you can use these methods into your advanced examples. All right. So now we are done with Python string formatting. Alright, so let's move on to next topic, that is Python slice and negative index. I think we have discussed it already, like in Python list and tuples, so we don't need to discuss it again. Alright, so I'm just gonna mark it some other color with orange. So this is done here. Okay, so if you want to learn it again, go back and watch the list and tuples and sets topics to understand slicing and negative indexing better. All right, so now let's move on to next topic, that is Python iterators. Okay, so this is going to be interesting. So in Python, an iterator is an object that represents a stream of data. So the thing is that iterators are used to loop over elements in a collection, such as lists, tuples, dictionaries, or even custom data structures. And while doing that, they loop on it one element at a time. All right. The process of iterating over elements is known as iteration. You could say that basically loops do the exact same thing, but they're not really. There is a difference. All right. And I'm going to get to that difference in the end when I'm done explaining to you iterators and when I'm done with examples. All right. So basically the built-in iter function or iter function, it is used to create an iterator from an iterable object, and the next function that you use after that is used to retrieve the next element from the iterator. All right. So when all elements have been exhausted, the iterator raises a stop iteration exception. So let's go ahead and let's do an example. Let's create a list and then use this iter method to basically, you can say, or retrieve the elements. So let's go ahead and let's just delete all of that. And now I will create a list here. Let's call it my list equals, I'm going to have numbers like 1, 2, 3, 4, 5. And then after that, I'm just going to have here my underscore iter, and then I'm going to use built-in iter function, and then I'm going to pass my list through it. All right. So once I've done that, now I have my list, you know, as an argument in the iter function, which means that now it's ready. It is ready to go through the list, and now I need to just retrieve the elements from the iterator. So what I'm going to do here is I'm just going to write here print next my underscore iter. Okay, so basically I can just simply copy it like this. So what it would do, that it would retrieve 3 elements, okay, by using this next method. So let's just save it and let's just go ahead and run the code and see what happens. So here you can see that 1, 2, 3. So if I want to retrieve all the iterators, I could do that, all the elements. If I go here, run it, you could see that I have now got all the elements. So what if I just print here another extra iterator? So what would happen? Let's just go ahead. Here you can see that it has raised an exception, all right, as I've told you, and it has stopped the iteration. So what if I want to use for loop? So let's just remove 3 of them. Now we have got this 2 elements. So what if I want to use for loop to retrieve the rest of the elements from this iterator? Okay, so this is interesting. You can use for loop as well with iterators. So all you have to do is you need to come here, and here you're going to write for item in my iter. All right, this is my iter, and you can see that it has iter function and all the list is in it. So now what I'm going to do is I'm going to write here a print statement which would essentially print item. Okay, So let's just save it and let's just go ahead and run the code. So, okay, I need to put a colon here, excuse me. So let's just go here and, okay, 1, 2, 3, 4, 5. And why is that? Because 2 of them are being printed out here. So if I comment these 2 print statements, now what's gonna happen? I don't know, let's see. It's still going to print out 1, 2, 3, 4, 5. Okay, so what if I go there and I just remove these print statements and I do not print these 2 values or elements that I'm getting? Okay, so then what's gonna happen? Let's see. I think it's gonna print out 3, 4, 5. So let's just see. Bingo, there you go. All right, so these are different experiments that you could do with a single example. It just teaches you how to think in different directions and get a little bit more perspective on coding. So as you see that in this example, the iterator my_iter, it basically iterates over the remaining elements of the list after the initial 2 elements have been retrieved. Like here, I've retrieved those 2 elements, but I've never printed them. That's why they are not being displayed in the output. All right. So basically Python, it provides built-in iterators for various types of data structures, as I've told to you, as I explained to you earlier, for, like lists, tuples, dictionaries, and strings. And basically you can also create custom iterators by defining classes that implement the iterator protocol. All right, so iterators, they are basically widely used in Python for tasks like processing large data sets, implementing lazy evaluation, and building custom data processing pipelines. If we talk about iterators specifically, they also provide an efficient and memory-friendly way to work with collections of data, especially when dealing with large or infinite sequences. All right, so now coming back to the key question, that what is the difference between iterators and loops? Are they even similar? So basically I would say they're not similar, but they serve a similar purpose in Python, which is to loop or iterate over a sequence of elements. However, there are some differences in them as well, which I can explain to you if you just give me a minute. So if we talk about an iterator, it is an object that represents a stream of data, while if we talk about a loop, it is a control flow statement that allows you to execute a block of code repeatedly. Okay, so if we talk about iterator, it provides a way to access elements in a sequence one at a time. While in loops, such as like for loops and while loops, it automatically iterate over elements in a sequence without the need for explicit iterator objects. Okay? If we talk about iterators, they are typically used when you need to manually control the iteration process, such as when implementing custom data structures or algorithms. While if we talk about loops, they are more high-level constructs compared to iterators, and they are often used for tasks like iterating over the element of a list, processing items in a collection, or even performing like repetitive tasks, you could say. So if I were to summarize all of that, I would say that iterators, they basically provide a low-level mechanism for looping sequences of data, allowing you to control the iteration process manually. While in loops, they provide you a higher level of abstraction for iterating over elements in a sequence, making it easier to write and read code for common iteration tasks. So depending upon your specific requirements, you're going to have to decide for yourself that either you're going to use for loop, while loop, or you're going to use iterators. So I think that's it from this topic of iterators. I hope you learned a lot in this topic. So now let's talk about our next topic, that is Python generators. So in Python, a generator is a special type of iterator that allows you to generate a sequence of values on the go, or you can say when you want to generate value, rather than storing them in a memory all at once. So you don't have to use the memory, you just produce value on the go. All right. So like you can say that as it is obvious from its name. So generators, they are defined using functions, and the yield keyword is used, which allows you to pause the execution of the function and yield a value to the caller. So let's go ahead and let's do an example so that you can understand this better. All right. For that, I'm just going to go here, remove all of that, and here I'm going to create a function and I'm going to name it countdown. And I'm going to pass an argument n, or a value n, put a colon here, and then I'm going to have a while loop inside this function, and I'm going to set the condition that n is greater than 0 always, and once it is that, I want to yield yield n, and then I simply want to decrement n. Okay, in other loops we used to increment this value, but here we are going to decrement. Decrement means basically you just minus 1 from the variable. All right, so here we go. So now what I'm going to do is I'm going to create a generator object here, my generator, and here I'm just simply going to use this method or function that I've just created, countdown, and here let's say I pass 5. Okay, so once I'm done with that, now I'm just going to write here a for loop, which is like for value, and then I'm going to write here in my generator. Okay, make sure that you write the spells right, otherwise it would give you an error. So you write your print, and then of course I'm going to pass value through it. So what's going to happen that it is going to print out numbers. It's going to count down from 5 till 1. Okay, so 5, 4, 3, 2, 1, and because of this condition here, it's not going to go below 1, like it's not going to go to 0, A1. All right, so let's just save it and let's just go ahead and just run the code and let's see what happens. So let me just clear it first, and then here you can see that it is saying yield n invalid syntax. So probably I have spelled the yield wrong. Oh yes, so here I just need to spell it like, okay, yield. So now you can see the color has changed for the keyword. So let's just save it, go ahead and run the program, and here you can see that 5, 4, 3, 2, 1. So mainly if I were to tell you that why these generators are better than iterators and normal functions, okay, so the first thing is memory efficiency. Like they are super memory efficient because they produces values on the go and you don't have to store them. Then the second thing is lazy evaluation. Generators, they basically use lazy evaluation, meaning they can only compute values as they're needed. All right, so this basically helps improve the performance by avoiding unnecessary computation. And the third one is that generators are simple and they're very easy to implement. Okay, so they are basically easy to write and understand, and it makes them a convenient way to generate sequences of values without the complexity of custom iterator classes. All right, so generators, they are basically commonly used in Python for tasks like processing large data sets, generating sequences of numbers, and implementing efficient data processing pipelines. So they also provide a powerful and flexible tool for working with sequences of data in a memory efficient and performance conscious manner. All right, so I hope you've got the point and now you understand this concept of generators. So we're done with generators. All right, so now let's move on to our next topic, that is Python decorators. All right, so Python decorators, that is a very, very impressive feature and a good feature. It allows you to modify or extend the behavior of functions or methods without changing their code. All right, so that's interesting. Decorators, they are implemented using functions themselves and the at the rate decorator name, whatever it is, that would be the syntax, and where that decorator name is the name of the decorator function. All right, so I'm going to give you an example so that you could understand it better. So what I'm going to do is that I'm going to create a decorator function first. So I'm just going to create here definition, and like I'm going to define a function, and then I'm going to name it as like my decorator, and then I'm going to write here func, which is an argument, and then what I'm going to do is I'm going to have another function inside the function, and this is going to be a wrapper function. Okay, so once I have that function, I'm going to have a print statement in it, and this print statement, let's say I'm going to say something is happening before the function is called. Okay, and then I'm going to actually call the function here. Okay, and after that I'm going to print again, and this time I'm just going to copy it, and I'm just going to say something is happening after the function is called. All right, so let's go here and paste it. Something's happening after the function is called. All right, so once I have done that, now I'm going to return to this wrapper function. All right, so I'll just come here, and then I'm going to return wrapper. Got it? So here, if you could see that this func function is basically the argument of this decorator. Okay, so let's just go ahead and let's just now create a decorator. So sorry, we have created a decorator. Now use this decorator. Pardon me for that. So let's go ahead and let's use it. So what I'm going to do is that I'm going to create another function, and let's call it say hello, and inside this function I'm going to simply print out hello, a simple hello, and okay, hello. So however, in order to use this function or in order to use the decorator function for this and modify the decorator function a little, for that what I'm going to do is that I'm going to write here the syntax that was at the rate and then the my decorator function. Okay, so now basically with this function can use this entire decorator function. All right, so now what I'm going to do is that I'm going to simply call this hello function, that is say underscore hello. So now I'm calling the decorated function which have been decorated, all right, by using the decorator function. If I do not add this syntax at my underscore decorator, all right, this function cannot be decorated without this syntax. So this is super important to remember. And here you can see that I've got the output, and something is happening before the function is called, and here like I've got hello, which was this function that we called, and you can see that we have basically implemented or decorated this function with this decorator. Like this function, we have used it to like this function was decorated by this decorator. All right, so hope you've got the point. So that is the basic concept of decorators in Python. So if we talk about this example again, my decorator is a decorator function here that takes another function which is func as its argument, and then inside my decorator there is a new function that I have initiated here, which is like a wrapper. Okay, this calls the function here. Okay, first of all it prints something, something is happening before the function, and then it calls the function, and after calling the function it prints out like something is happening after that. So then finally it return wrapper. Okay, so this at my decorator is the syntax that is used to apply the my decorator to the say hello function. So when say hello is called, all right, here, this is actually calling the wrapper function here, this one, which was created by the decorator, which in turn calls the original say hello function along with the additional behavior defined in the decorator. All right. So decorators, they can also take arguments, allowing them to be more flexible and configurable. So what I'm going to do is I'm going to do another example here. So first of all, I'm going to write here, let's say repeat function n, and then I'm going to write here colon. And after that, I'm going to define another function, let's call it decorator, and then I'm going to pass function through it. And once I'm done with that, now I'm just going to define another function in it that is going to be wrapper. And here I'm going to give it two arguments, static args, and then comma, and double static k wargs. So do not get yourself confused with these two arguments. If you talk about static args, that is like arbitrary arguments. And then if we talk about double static kwargs, that is arbitrary keyword arguments. All right, I'm going to explain to you later what these are and what they do. For now, let's just keep on moving and keep on writing code. So now I'll just put in colon here, and in here I'm going to have a for loop, for underscore, and then I'm going to have here in, and then I'm going to put a range of n, like the argument n that we have in the repeat function, and then repeat is a decorator basically, and then I'm just simply gonna call a function here with the arguments, of course. So I'm gonna have here args and static key wargs. All right, so then I'm just simply gonna return wrapper here, and once I do that, so this return wrapper has to be here like here. Okay, so make sure that indentation is right. So then I'm going to return decorator. Okay, so make sure that indentation is also right here. So after that, what I'm going to do is I'm going to, similarly like the last example, I'm going to create a function named as hello. In here I'm going to have name. Okay, and in here I'm going to print a statement. I'm going to format it with f strings, and then I'm going to say hello, and comma, space, and then I'm going to have here name. Okay, this is called f string formatting. If you remember, we just talked about it previously. So now what I'm going to do is that I'm going to go ahead and call this function. But before calling this function, we need to decorate this function. So for that, I'm going to call decorator here at repeat. But if you remember that last decorator that I called, it didn't have any argument, right? So in here, what I'm going to do is I'm going to have an argument, which is like 3. So this function is going to repeat itself for these number of times. So let's see what happens. I'm just going to go ahead and call this function. So let's just save it. Let's just go ahead, and before we go ahead, we just pass an argument here, which is going to be name essentially. So I'm just going to name it Bob. So let's just go ahead and let's run it. Now you can see that it is printing out like hello Bob 3 times on repeat, this decorated function here. All right, so in this example, if we talk about the repeat specifically, this is a decorator that takes an argument n, which means, or which specifies that how many times the decorated function should be repeated. Then we are gonna have at repeat 3, like here that you see that we have called the decorator. This is a syntax that applies the decorator with an argument of 3 to the hello function. All right. So if we talk about decorators specifically, they are commonly used in Python for tasks like logging in, authentication, caching, and more. They basically provide a very clean and elegant way to extend the functionality of functions or methods while keeping the code modular and easy to maintain. So if we talk about these static args, which is like arbitrary argument, they're used to pass a variable number of positional arguments to a function. The static before the parameter name, like here, like this one, it represents that the function can accept multiple positional arguments. All right, so inside the function args, it becomes a tuple containing all the positional arguments passed to the function. While if we talk about this one here, arbitrary keyword arguments, they're used to pass a variable number of keyword arguments to a function. Okay, so the double static here before the parameter name kwargs, it represents that the function can accept multiple keyword arguments. All right, so I hope I made this point clear to you. So that's it for decorators functions. I hope you've learned the concept. Now go ahead and practice it so that you can learn even more. So that's it for Python decorators. Alright, so now let's move on to our next topic, that is Python file handling. So Python file handling is all about reading the file, writing the file, and manipulating the file contents. Basically file handling is all about that, okay, mainly. So then there are different modes that you could use when you're opening up a file. You could use read mode, write mode, append mode. There are a lot of different modes that you can look into. I'll put the link in the description of Python documentation where you could take a look on all of that. So I'm not going to get into the theory of file handling because I just simply think that it's going to waste a lot of our time. We just go directly and start to do an example or do multiple examples so that you understand the concept better. All right, so let's just go ahead and let's just simply start writing code. Let's just remove all of that. I'm going to import OS, that is a module or library which would deal with file handling. All right, so first of all, I'm going to create a variable named as file. In here, what I'm going to do is that I'm going to have an open keyword. Here I'm going to write the file name, which is essentially going to be file.txt. So I already have this file.txt created on my desktop. All right, so if I just go here, if I ls, so here you can see that I have file.txt. All right, so if I want to see the contents of file.txt, I could just see that. All right, so these are the contents of file.txt. So let's just go ahead and let's just try to read it. So once we've done that, now I'm going to select a mode. So in order to select the mode, I want to open it up in the read mode. So I'm just going to write here R. All right. And after that, what I'm going to do is that I'm just going to print here file.read. And in the end, I want to make sure that I close this file. Okay, so whenever you are reading, writing, or working with a file, make sure that you close it. All right. So let's just save it. Let's go to the terminal and let's try to run it and let's see what happens. So what I'm going to do is I'm going to write here Python 3 hello.py. And here you can see that it has read the file successfully. So now you can also read this file line by line. All right, so for that you have read line, and you could save it. If you go ahead and if you try to read it, here you can see that it has read the first line out of the text file only. All right, so you can read multiple lines. For that you'll use this read lines function. So let's just save it and let's just go ahead and run it. And here you can see that it has essentially read every line and put it into a sort of a list. All right. So Now another thing that I want to talk about is you want to, let's say if you want to read some specific characters, let's say I want to read only 5 characters from my file, so I could do so. All right, I'll just have to write here 5, and then it would read only 5 characters. So let's just save it. Let's just go ahead and let's try to run it, and here you can see that it has read only 5 characters. So for read line, basically you could do the same. From the first line, I want to read, like, let's say 8 characters. All right, so I'll just save it. Let's just go ahead and try to run it, and here you can see that it has read 8 characters out of the file. All right, so now let's quickly move on to writing inside a file. So here you can see that we have in the file, we have a few contents. So when I write it, so what it's gonna do, that it is going to you can say replace all of that and write new text. All right, so if I append it, if I'm in the append mode, it's not going to replace everything, it's just going to write right next to it. So I'm going to show you both actually. So let's go to the write mode, and here instead of having like a print method, I'm just going to write here file.write, and then I'm just gonna basically enter text that I want to write. Okay, so here I want to write new text. Okay, so let's just save it. Let's just go ahead and let's see what happens. So I'm just gonna run this thing, and here you can see that I have successfully ran it. So what I want to do is that if you want to read it now, I'll just go ahead and let's say I'm just going to comment this thing here, and let's say I'm reading this file. All right, and I want to print it. Let's say I go here and I write here file.read, I save it, I go here and run the program, and here you can see that now it has replaced everything and written this thing right here. I want to write new text. So once you are done with that, now you can also append. You can go to the append mode and you can basically add text to your file. So this time the difference between writing mode and append mode is that it is not going to replace the current text, rather it is going to add text right next to the content that is already available. So right now our file has I want to write new text. All right, so I'm going to go into the append mode, and from here I just want to write I want to write another text. Okay, which is another new text which is different. So after that, once I do that, I'm just gonna comment it. Okay, so let's just save it. Let's go ahead, and you can see that our file has executed without any errors. So now what I'm gonna do is I'm just gonna simply comment this and uncomment this one. So I save it, I go ahead and I try to run the code, and here you can see that it's giving some sort of error right now, and the reason behind that is because I didn't change the mode here. So I'll just change the mode to R, and then let's save it. Let's go ahead, run it now, and here you can see that I want to write new text was the old line, and then it has appended that text. I want to write another new text which is different. So file handling is pretty much it. That's the entire thing that you could do. There are some other things, other stuff that you could do with it, so let me show you that as well. So if you have a file, let's say if you want to remove a file, okay, you could also do so. So let's just go ahead and let's just try to remove a file. So the thing is that if you want to remove a file, you could use the built-in method, which is like os.remove. all right, so you could do like basically if you have a file which is essentially, let's say, file.txt like this. So let's say if you want to remove it, so all you have to do is you have to write here file.remove, and then you're gonna have file name, which is essentially file.txt. You do not need this line. You do not need to open the file. What if I do like os.remove? So let's just save it, because file was not defined. I first wanted to define it and then remove it. But let's say that if I do it directly. So let's just go ahead and let's just try to run it and let's see what happens. So here you can see that it has executed successfully, and if I now do ls here, you can see that file has been removed. All right. So if you want to basically check if a specific file exists, you can put a check. If the file exists, then just delete it. If it doesn't exist, do following, all right, or something like that. So what I'm gonna do is I'm just gonna write here an if statement, if os.remove, and then I'm gonna write here the file name, which is essentially gonna be file.txt. Then what I want you to do is that I want you to os.remove file text. So and then I'm gonna have an else block here, in which I'm simply going to like put a colon here, else block, in which I'm simply going to have a print statement, in which I'm gonna say this file does not exist. Okay. So hold on. One thing that I need to change here is that I need to write here os.path.exist. All right. I'm not sure if it is exist or exists, so let's go ahead, save it, and let's check. You need to give path in both cases. So if your file is existing into another directory, you're gonna have to need to give entire path of this file. Okay, so let's just save it. I'm not giving any complete path here because I'm running the code Python program in the same directory. All right. So let's just go ahead and let's try to run the code, and here you can see it says os.path.exist. I think it is exist, right, as I've told to you earlier. So let's just save it and let's go ahead and check it, and here you can see that it says this file does not exist. And why is that? Because we already have deleted it. So let's just quickly create the file, and let's just put a message here as well, like print file deleted successfully. All right, so let's just save it. But before saving that, I think I need to create like a file here. So for that, I'll just simply write here nano file.txt. So what it would essentially do, that it would create the file. I'll save it, and I will ls here. Here you can see that we have file.txt. Okay, it is existing right now. So I'm just going to clear it up. This program is saved, hopefully. I'm going to make sure of that, and then I'm just going to run the code. Okay, run the program. So here you can see that it says file deleted successfully, and if I do ls here, and here you can see that now file.txt doesn't exist here. All right, and of course if I run the code again, it is gonna say this file does not exist. So I hope you've got the point. You have learned the fundamentals of Python file handling. So go ahead and practice it as much as you can. I have the link in the description for file handling documentation of Python. You can go ahead and study it and do your own coding practice, and we're done with Python file handling here. And just remember one thing, that file handling, it is an absolutely essential aspect of programming, especially for tasks like that involves input and output operations, or let's say data persistence. So if you are able to work with file handling in Python, you can work with files efficiently and effectively in your application. So if you're building up a web application or any other sort of application, and you need to deal with files like reading files, writing files, and opening them up, appending, or performing any sort of operation, then these file handling concepts, they are going to be super compulsory for you to learn. All right, so now we're done with file handling. All right, so let's move on to our next topic, that is discussing JSON in Python. So basically we're going to discuss two main methods, json.loads and json.dumps. And I'm going to explain to you in a while that what these two methods they do. All right, so first of all, I'm going to explain to you what is JSON. JSON stands for JavaScript Object Notation. It is a lightweight data interchange format that is easy for humans to read and write and easy for machines to parse and generate. Okay, it is commonly used for transmitting data between a server and a web application, usually for the purposes of storing configuration settings and exchanging data between different programming languages. All right, so usually JSON data is represented as key value pairs similar to Python dictionaries, and it supports the data types like strings, numbers, booleans, arrays, objects. It also supports null, all right, for empty value representation. So let's just jump ahead and let's just do an example. So first of all, I'm just going to give you an example of JSON data. So here, let me just remove all of that. And here you can see that this is the basic example of JSON data. All right. So like here you can see that we have the data in the form of key value pairs similar to dictionaries. So in Python, you can work with JSON data using built-in JSON module, which provides functions for encoding Python objects as JSON strings. For encoding Python objects as JSON strings, you're going to use json.dumps method, and for decoding JSON strings into Python objects, you're going to use json.loads function. So what I'm going to do, that this is a format of JSON data, and we're going to use it for our examples. Here I'm just going to import the JSON module in Python, and I'm going to enclose this into a variable named as person. Okay, this whole entire JSON data. So this is going to be a data of a person. So what I want to do is I want to convert this Python basically dictionary to JSON string. All right, so in order to do that, all I have to do is that I have to use a function named as json.dumps. So to use that, basically what I'm going to do is I'm going to write here JSON string, and then I'm going to write here json.dumps, and then I'm going to pass the argument of the variable named as person, which has the entire JSON data in it. So after that, what I'm going to do is I'm going to write here print JSON underscore string. All right, so the thing is that basically what I'm doing here is that I'm converting Python dictionary to JSON or JSON string. All right, so let's just save it and let's just go ahead and let's see what do we have on the output. So here you can see that now it has successfully encoded the Python data as JSON. Okay, so now let's move forward and try to do an example of decoding JSON data into Python objects. So basically what we're going to do is that we're going to convert a JSON string that we have created into Python dictionary now. So we have this JSON string here. What I'm going to do is that I'm going to create person dictionary, and here in the comment I can write my intention that what I'm going to do. I'm going to convert JSON string to Python dictionary now. So for that, of course, I'm going to use python.loads method. So here I'm just going to have %dictionary equals, and then I'm going to have here json.loads, and then I'm going to have here, I'm going to pass through it JSON string variable that we had there. So now what I want to do is I want to write here a print statement in which I am going to write here person_dictionary, and then I'm going to have here name. Okay, so the output should be Alice. All right, because I'm basically giving key here name, so it should print out the output as name, which is going to be Alice. So I just want another like print statement here, and let's say right here person dictionary, and let's say here I want to print out address, and from address specifically I want the city, not the country, but I just only want the city. So for that I'm just going to give here the key which is essentially city. All right, so there you go. So let's just go ahead and let's just save it, and let's try to run the code again. So here you can see the output. This output is basically the JSON string thing that we have done previously, and here you can see that specifically we have converted the JSON string into Python dictionary, and out of that dictionary we have fetched these two values successfully. All right, so I hope you've got the point, you've understood the concept. So that's it for JSON. Basically this JSON module, it provides a convenient way to work with JSON data in Python, enabling you to easily serialize and deserialize data for communication with web services, data storage, and other tasks that you may find yourself into. All right, so that's it for this JSON topic. All right, so now let's move on to our next topic, that is regular expressions. So regular expressions in Python, they are used for searching, matching, and manipulating text patterns. All right, they provide a concise and flexible syntax for describing text patterns, which can be used for tasks such as pattern matching, text extraction, validation, and even substitution. So if you might have noticed that sometimes when you are putting in your email into some website, into a form, let's say you do not write hello@gmail.com, instead you just write hello123 or something like that, it would give you a red error saying that this is not an email address. So how is that even possible? So on the back end of that, and this thing is being used, which is called as regular expressions. All right, so you define a pattern with regular expressions, and you want to make sure that the user or the reader or whoever is putting in the email address, they put in the email address right. So you do not accept anything that is not an email, and you do that, you validate that field of email basically by using regular expressions. All right, first of all I'm gonna basically show you how to search a pattern, and then I'm gonna show you how to match a pattern, and then I'm going to show you that how you can find all the occurrences of a specific pattern, and then finally I'm gonna show you how to substitute occurrence of a pattern in a string with the replacement string. All right, so these are the examples that I'm gonna do. Then I'm just going to define a regular expression pattern which can be complex, and then I'm going to explain to you what it exactly does and how you can basically go ahead and use it. All right, so let's just go ahead and let's do our first example. So for that I'll just simply go here and let me remove all of that. So I'm just going to import RE first hand here, and then I'm gonna have a text here which should go something like this. Let me do it like hello world. All right, and then I'm gonna have a pattern here which is gonna be something like this world. All right, I want to match this pattern. Then I'm going to have match equals, and then I'm going to have here re.search. Then here I will have pattern, comma, and then text. All right. So once I have that, after that I'm going to have here match, and then I'm just going to have here pattern found. Okay. And then I'm just going to put a comma here, and then I'm going to say match dot group. All right. So I think that's pretty much it. So of course this pattern world, it exists here, and this is the first occurrence of it, so it's gonna get it, and then of course it's gonna match, so it's gonna say pattern found. All right, so let's just go ahead and let's just check it out. So we just go here and we clear it, and then we run the script, and here you can see that it says pattern found world. All right, so this match.group, it would basically print out the pattern that have been matched. Okay, so this re.search, what it does, that it search for the first occurrence of a pattern in a string. All right, so next I'm going to show you that how you can use re.match pattern. All right, so let's say instead of world here I have hello, and then instead of search here I have re.match. So after that, here basically instead of pattern found, I'll do pattern matched. Okay, so what it does, that this pattern dot match, re.match, what it does, that it matches a pattern at the beginning of a string. All right, so the beginning of a string, this would be matched, and then it would print out something like that. So I just go here, print it out, and here you can see that it says pattern matched hello. Okay, then there is something called as re.findAll, which takes the first argument, which is a pattern, and then the second argument, which is text. All right, so this re.findAll, what it does, that it find all occurrences of a pattern in a string. So let me just modify this text a little bit. So let's call it hello 1 2 3 world 4 5 6, and next what I'm gonna do is I'm just gonna go here, and instead of having a text pattern, I want to have a regular expression pattern. So the way to do that is that I'm just going to write here before pattern, I'm going to write R here, and then I'm going to write here /d plus. All right, I'm going to explain this to you in a while at what it does. First of all, I'm going to just write here find all. Okay, and then of course we have pattern, we have text, and then I'm going to say matches found. Let's call it matches found, and then instead of match group, I'm gonna have here matches. All right, and I'm gonna call this variable matches. All right, so let's just go ahead and save this. So basically this d plus, it has to do something with integers. All right, so here I just also need to do matches. All right, so let's just go ahead and save it, and here you can see that matches found 1 2 3 4 5 6. So what this d does, it looks for an integer. Okay, it is gonna look for an integer. So if we talk about this R specifically, this is gonna say that it is a regular expression. This is a syntax, you can say, and then the regular expression, you're gonna call or add that into these single quotes. So this entire thing is the regular expression. So if we talk about /d first hand, this /d is a shorthand character class representing any digit. it is equivalent to the character range from 0 to 9. Okay, so this plus is basically the quantifier, right? This plus is a quantifier that matches one or more occurrences of the preceding element, which is in this case is a digit or /d. All right, so /d plus, it matches a sequence of one or more digits. All right, so 1 2 3 matches because it contains one or more digits. All right, and then 4 5 6 matches because it contains one or more digits. All right, and you can see that it has skipped this hello world. So here you can see. So next I'm gonna talk to you about a method, a built-in method, which is sub. All right, so, or substitution, okay, which basically substitute occurrences of a pattern in a string with a replacement string. All right, so let's just go ahead and let's just do a simple example for that. So here I'm just gonna have a text called as hello world. All right, and then I'm gonna have a pattern as, let's just call it simply world. All right, and then I'm just gonna have here replacement string, which of course I'm gonna use to substitute it. And here I just call it simply, let's call it Python. Okay, and then here instead of matches, I'm gonna have new underscore text, and then I do it like re dot, and I use dot sub, which stands for substitute, and then I'm gonna have here pattern, I'm gonna have text, but before this thing text, I'm gonna have replacement, okay, which is this one here, and I don't need this if condition here. So here I just need to print it out basically. So I'll just write here print in order to display it on the screen, so that we know that changes have taken effect. So we write here new text, and then I'm gonna write here new underscore text, okay, which is this variable which would be printed out. All right, so let's just save it. Let's just go to the terminal and let me just clear it. And here I'm gonna run it, and you can see that giving me some sort of error, and the reason behind that is I haven't put a comma here. Okay, so let's just go ahead and run it, and here you can see that it says new text hello Python. So it has replaced this world here. First of all, it has identified or looked for the occurrence in the text, and then it has basically replaced that specific string that it has found with Python. All right, so now what we're gonna do is that I'm just gonna go through a simple regular expression. It's not a simple, but it's a complicated one, and I'm gonna explain to you each and everything that it does. Okay, so regular expression, basically it supports a wide range of pattern matching features, including character classes, quantifiers, anchors, groups, and more. So what I'm gonna do is, let me just remove all of that, and here what I'm gonna do is I'm gonna create a pattern, and I'm gonna explain to you what this does. Okay, so first of all, I'm gonna have here /b, and then I'm gonna have here A to Z. Don't worry if you don't understand this at the moment, because I'm gonna explain to you each and every single thing that I'm writing here. Okay, and then I have a percentage, then have a plus, and then we have minus, and then we have a bracket here, then we have a plus sign, we have /, and then we have dot, and then we have bracket, we have A to Z, and then R, we have A to Z, and then we close this bracket, and then we have a something like this 2, and then comma, then we have we close this bracket, and then we have /b. All right, so this here is a basic form of a regular expression, what exactly that is. So you might have noticed that I have done some text patterns, right? So that is one way to do it, but you can say that more professional way to do something, because when you're looking for example, if you're creating a pattern for an email, all right, so that is the pattern. You want to create something that will identify the pattern. All right, so for that you're going to create something like this, the regular expression. Okay, your regular expression might look like this, not essentially text only. Okay, so basically this pattern that I have written here, it is a regular expression which is designed to match email addresses. Okay, so I'm going to break down its components so that you could understand it better. So first, let's talk about this /b here. This is a word boundary anchor. It matches the position between a word character, like it could be alphanumeric or underscore, and a non-word character. Okay, so that's what it is for. So if we talk about next, this thing here, okay, this bracket, including this plus, all right, so what it does, that it is a character class representing the local part of the email address. It matches one or more occurrences of alphanumeric characters, which is like here from A to Z, and then A to Z. It could be capital A to Z, it could be small a to Z, and then digits, which is like 0 to 9. It could be any digits, and the special characters, it could be like dot, it could be underscore, it could be percentage, plus, minus. So here, like if you, for example, if you have an email like Bob Bob is gonna be identified by this, so it's gonna allow the capital Bob or small or a mixture of that. And then let's say you have Bob 361 number, it's gonna allow that. And then let's say you have Bob 361 underscore or something like that, it's gonna allow that as well. Then after that you have the literal character. Okay, so I just forgot to put it here. I'll put it like this. So this plus a, all right, hold on, I think I need to change this expression a little. Okay, I might have had a typo here. So plus a, and then we have, of course, at the rate, and then we have A to Z, and then I'm just gonna have here. Okay, so here after at the rate, what I'm gonna do is I'm gonna have, for here I'm gonna write something like for Gmail, for Hotmail, I'm gonna write a regular expression. For that I will just write here A to Z and A to Z, all right, and it can be 0 to 9 because sometimes people have domain names like for example, if you have a domain like abc123.com, then in that case you're gonna need this. All right, it could have a dot, it could have a hyphen, right? So then after that I'm gonna have a plus and then slash and dot, and the rest of it is okay. So this literal, let's start from here. This literal character is for at the rate of. It separates the local part from the domain part of the email address. And then this part, as I've explained to you, right? So what it does, that it is basically a character class representing the domain part of the email address. It matches one or more occurrences of alphanumeric characters like A to Z, capital A, Z, you know, these are like you could say words, and then you have digits, 0 to 9, and then you have special characters, dot, and hyphen. Okay, other than that it won't allow anything. All right, it would give an error. So then we have / dot. Okay, so this is an escaped literal character, dot. Okay, it matches the dot separator between the domain name and the top level domain. All right, and after that, of course, after this dot, it could be .com, .net, it could be anything. So this is basically, if you come down here till here, this is a character class, okay, representing what it represents is that it represents the top level domain of the email address. It matches 2 or more occurrences of uppercase or lowercase letters in the form of AZ, capital AZ, or small az. The pipe character here that you see between capital AZ and small az, it represents that the character inside the character class is treated as literal character. Okay, the pipe character that you see here, it is treated here as a literal character. And then you have /b here, which basically what it does is that it is a word boundary anchor. It ensures that the match ends at a word boundary. You cannot end it as a number. Okay, so here you cannot start with a number, and here you can also not end with a number, because top level domain cannot have a number. So I hope you've got the point, and you understand the concept of regular expression and purpose of it. So now go ahead and do your own examples and study regular expressions in detail. So regular expressions, they can be complex, but they are incredibly powerful for text processing tasks. When working with regular expression in Python, it is important to use raw strings like this one here. Okay, so this one is called raw strings. So hold on, let me just remove all of that. So this one is called raw string. So you're gonna use that, and inside of that you're gonna write regular expression here. Okay, so if you want to avoid issues with backslashes and patterns, you have to use this raw string. All right, so additionally, regular expressions can be optimized for performance, especially when dealing with large amounts of text. And you can use them for substitution, you can use them for email addresses validation, or any sort of validation that you are looking for, any sort of data validation. So I hope you've got the point, and you have now basic and understanding of regular expression. Alright, so now let's move on to our next topic, that is Python input. So the thing is that why you wanna even have Python input? So the thing is that when you want to take input from the user and you want to work on it, you want to manipulate it, and you want to use it, in that case you're going to use input function. In every other programming languages you have different functions for this purpose, but in here in Python you have the input function specifically dedicated to taking the input. All right, so input function is used to accept user input from the keyboard. It prompts the user to enter a value and returns the entered value as a string. Okay, so I'm going to talk to you about what if you do not want a string. So I'll just in a moment I'll explain that to you. So let's just do a simple example of using the input function to get the data, and then let's see how we can work with input or work with the data. So I'll just simply call it input, and let's say you want to get the name of the person. All right, so let's just go ahead and let's just simply write here name variable, which is a variable. Then I write here input, which is a built-in method, and then I write here enter your name please. Okay, and then what I'm going to do is I'm just going to print here, print and then I'm gonna write here hello, comma, and then I'm gonna write here space, and then I'm gonna write here plus name, plus. All right, and of course then I just want to write here exclamation mark. So I'll just save it, and if I go ahead and if I run the script here, you can see that it says enter your name please, and let's say I enter here Chris, hit enter, and it says hello Chris. All right, so this is a simple way to use the input, and let's just go ahead and let's do another thing. In this thing here, first of all, let me just explain it to you, and then let's do another thing with the you know, taking the input as an integer or float or something like that. So here, when basically the code is executed, it has displayed the message with this message, enter your name, all right, on the console here in the terminal. So prompting, it basically prompts the user to input their name. All right, the user can then type their name and press enter, as I have done it earlier. After the user enters their name, the program will read the input and assign it to the variable name here, and then I would simply, you can see that I have printed it with hello, and then I have just got the name here. So whatever user will write, it would be stored into the name variable, and then the name variable would be printed here with a hello. All right, so it's important to note that the input function always returns a string, all right, regardless of what the user enters. So if you need to convert the input to a different data type, such as integer or float, in that case you can use typecasting. So if you don't know what typecasting is, I'll explain to you in easy and simple words that, for example, when you need to convert a data type into another data type, that's basically called as typecasting. Okay, so for example, in this case, we'll get the string. Let's say if we want to know the age of the, you know, the user who's inputting it. So in that case, it is going to take it as a string. So age is a number, and as a string, it's of no use. So for example, if you need to take two inputs, 1 plus 1 or whatever, let's say user gives it like 80 and then 20. Okay, so these are two integer inputs. All right, so in order to add them, subtract them, or perform any sort of integer operation or arithmetic operation on these two values, you need to convert them, because they are as a string, they're taken as a string. You need to convert them into something meaningful, right, which is integer, so that it can perform arithmetic calculations, right? So let's just go ahead and let's see what I'm talking about. So here, let's say input, enter your age please. Okay, so of course it's gonna be taken as a string. So what I want to do is that I want to typecast it right here. I could do it in the next step as well, but I'll just directly do it here. So what this integer function would do, that it would typecast whatever value comes from a string to integer. Okay, so then what I'm going to do is here, I'm just going to write here UR, and then simply I'm going to write here plus, and here I'm going to write here age, and here let's write here str age, and then I'm going to write here years old. Okay, so let's just save it. Let's just go ahead and let's just print it out. And here you can see that it says enter your age please. Let's say I write here 28, hit enter, and here you can see that it is giving us an error, and the reason behind that, okay, this is still name, so let's just change it to age. Okay, so save it, go ahead, run the code again, and I'm gonna add 28. So it says you are 28 years old. All right, So this is how you work with the input. All right. So in this example, the integer function here, it was used to convert the user input into the integer, okay, which was initially a string, of course. So once, like here, you can see that it has converted this string to integer before its assignment to this variable age. Okay, so I hope you're understanding the concept, because these are two different things. And then basically, if you have used it like integer, similarly you can use float for converting to a floating point number, or any other appropriate type conversion function that is needed. You can convert this string into any other data type by using this, you could say, like typecasting. Okay, so let's do another example quickly. Let's call this number 1. Input, enter first value for addition. Okay, and then I'm just gonna have number 2. I'm just simply going to copy it, and here I'm gonna change it to number 2, and here I'm just gonna say enter your second value. Okay, so then after that I'm gonna create addition add variable, and I'm just gonna say number 1 plus number 2, and then I'll simply just want to print add. Okay, so let's just save it, and here I go, and let me just clear it, and I run the code. It says enter first value for addition, so I just add 20. Enter second value for addition, I just add 12. So here you can see that it has returned as 32. Why is that? Because we have successfully converted the string into integer. If we wouldn't have done it like this conversion, otherwise it would have taken it as a string, so it would have given error, or it would have just like displayed like, you know, 10 plus 20 or 20 plus 12 or something like that. All right, so I hope you've got the point. So now we are done with Python input. All right, so now let's move on to our next and final topic, that is Python object-oriented programming. So object-oriented programming, or you can call it OOP, is a programming paradigm that organizes code into objects, which are instances of classes. So each object contains a data, which is also known as attributes, and methods, which is also known as functions. So these attributes and methods, they operate on this data. All right, so Python, like other object-oriented programming languages, is an OOP language that supports the creation and manipulation of the objects. All right, so what I'm going to do is I'm going to explain to you key concepts and in object-oriented programming, and basically the key concepts are classes, objects, attributes, methods, inheritance, encapsulation, and polymorphism. So I'm going to go through them one by one. So first of all, let's talk about classes, and as we talk about classes, I'm just going to go ahead and I'm also going to create a class. So like in Java, you also create a class with the class keyword. So in Python, it is the same. So if I define a class here, class person, so a class is just a blueprint for creating objects. It defines the attributes and methods that the objects will have. Okay, so in Python, classes are defined using the class keyword that I just mentioned. So in class, first of all, you need to have a constructor. So that is a must for a class. So in Python, the way you define a constructor is something like this. You write here init, and then you write here self, then you write here, okay, I write here name, age, and then I'm gonna have here self dot name, and here I'm gonna put it equal to name, and I'm gonna have self.age equals to age. Okay, so then I'm gonna define another function named as hello, and I'm gonna put self here. Self, I'm passing through it as an argument, and then I have a print statement here, which I'm gonna say F string literals I'm gonna use here. So I'm gonna say hello, my name is, and here I'm gonna say self.name, and here, sorry, I'm gonna have to put it in here, and I am self.age years old. All right, so this is how you can basically create methods inside the class. So once you've done that, now I'm gonna come out of the class. So in Python, basically you have indentation. So when I basically bring the cursor here, I am technically outside the class. All right, so outside the class, what I'm gonna do is that I'm gonna create objects of the person class. So this person one, this is an object. So I'll just write here person, and then I'm gonna write here name, which is gonna be, let's say, Chris, and then I'm gonna write here 30 years old. Chris is 30 years old, and then I'm gonna write here person 2, which is an object definitely, and I'm gonna write here person, and then I'm gonna write here Bob, and Bob is, let's say, 28 years old. Okay, so the thing is that here you could see that what is this person. So this person is basically this class, which is like taking two arguments like name and age from here. You can see that the constructor that we have defined here. So this ignores the self because it is a part of the constructor, and it's basically taking two arguments, name and age. And here you can see that inside this person one object, we have created the object in this code here, and this object is taking the value from here. Okay, so Chris, which is a name, and 30, which is the age. All right, so basically what's going to happen is that if you want to access these attributes, for that what you're going to do is you're going to have to use here, you're going to have to use print function if you want to display it. And for accessing it, you're going to write here person1 dot name. All right, so the output for this person1 dot name is going to be Chris. All right, so if you write here person1 dot name, and then you print out here person1 dot age, now it's going to print out the age of it as well. All right, so let's just comment this line, because I'm just gonna have to show you the name here, and then I'll show you that how you can print both by using the hello function. All right, so if I save it, if I go to the terminal, if I run it, and here you can see that it has printed out Chris. In the similar fashion, I could print out age as well. So if I save it, and if I go back here you can see that now it has printed out the age of Chris. So let's say if I want to call the function here, I will write here person2 dot hello. All right, so what it would do, that basically it would print out the name and the age. It would get it. You can see that it has arguments like self, so it would get the arguments for self from here with self.name and self.age, and which is a complete object right here. So what it's gonna do is that when you save it and when you print it, it's gonna say, hello, my name is Bob, and I am 28 years old. All right, so let's just save it. Let's just go ahead and let's try to run the code, and here you can see that it says, hello, my name is Bob and I'm 28 years old. So this is a perfect example of using attributes and methods in object-oriented programming. So these two are attributes like name and age, and this one is the method that you could see here. All right, So functions, they are basically called methods in object-oriented programming. So if we talk about objects, if you were to understand it, if you were to define it, so an object is an instance of a class, all right? It is created using the class's constructor method, usually which is init, like this, all right? And it can have its own unique data and behavior. So you can see that it has its own unique data and behavior in here, all right? So next we have attributes. Attributes, basically, they are the variables that are associated with the objects. They represent the object state or characteristic. In Python, attributes are accessed using the dot notation, and it says like object dot attribute. So this is the object self, and this is the attribute name. All right. So here you could see that we also used the print statements here, right? If you remember. So in this case, this is the person1 is an object, and dot age is the attribute. All right. So if we talk about methods, so methods are functions defined within a class that operate on the object's data. They represent the object's behavior and can be called using dot notation, like object dot method. Like we had here something like this, like person2 dot hello. So this was the method that we called, and we called it using object which is person2. All right. So there is another key concept in, there are three key concepts in object-oriented programming: polymorphism, encapsulation, and inheritance. So let's talk about inheritance first. So inheritance is the mechanism by which a class can inherit attributes and methods from another class. So you can inherit data, attributes, methods from another class and use them somewhere else into another class. All right. So a class that inherits from another class is called a subclass or derived class. All right. And the class it inherits from is called a superclass or base class. For example, if you have a superclass of animals, and then you go ahead and you have a subclass of, let's say, dog. All right. So dog is gonna inherit from the class animals, the attributes, the methods, and stuff like that. However, if you notice that animals is like a vast thing, okay, it's a big thing. In animals, you have birds, you have you have carnivores, you have herbivores, you have everything. But in the class dog, which is being inherited from the class animals, it would have really specific type of data, okay, only related to dogs. So you could have a bird class or eagle class, and it would inherit only the things that it requires from the animal class. So animal class is really big, it's a super class, and it is only inheriting the stuff that it needs from the superclass. All right. So an example for that would be, let me just have here. Okay, so let's have this class right here. Let me remove these objects. So we have this one class here, which is person, right? So I'm gonna create another class, which is gonna be student, and I'm gonna use inheritance in it. So then I'm gonna have a constructor for it, which is init, and then I'm gonna have self comma name comma age. All right. So and then I'm gonna have student ID here underscore ID. All right. So now what I'm gonna do is I'm going to have to define a super constructor in it, super dot init. All right. And in here, what I do want is that I want to inherit like name and age. Okay. So then I'm gonna write here self dot student student ID underscore ID equals student underscore ID. Okay, so then I am going to define a method, which this method is going to be, let's call it study self, and then I'm going to have a subject here, colon, and then I'm going to print with the string literals. So I'm going to have here self.name, all right, is, and then I'm going to say studying, and I'm going to write here subject. All right, so I think after that what I'm going to do is I'm just going to close this bracket. Now I'm going to create an object of the student. So for that I'm just going to come out of this class. So now we have two classes here. One class is person and one class is student. So here you can see that this student class is inheriting this person class, and here then you can see we have a constructor, and we are calling this super constructor from here. Okay, because we have inherited the class, now we can work with its constructor and methods. So here we are calling the constructor of this class. The own constructor of this class student have like three things: name, age, and student ID. And then it has a built-in method which is study, and then it has like subject as an argument. All right, so the thing is that it can also access name and age from this class of person, and it can work with the subject here. Basically, when you are going to create an object for a student class, you can work with two methods like study and hello both. All right, and you can work with three like attributes. One is student ID from student class, and then you can work with name and age from the person class. All right, so now let's go ahead and let's work with this thing. I'm just gonna write here student. I'm gonna write here equal, then I'm gonna write here student, which is like this. Okay, and then I'm gonna write here Chris, and I'm gonna put a comma, 20 years old, and he's studying the subject, like let's call it S1, 2, 3, 4, 5. Usually in universities you have these subject codes, so I'm gonna have that. So we have a student object named as student. So now what I'm going to do is that I'm going to access attributes, and I'm going to call methods inherited from the person class. So for that, what I'm going to do is I'm going to come down here, and I'm going to call here print student dot age, okay, which is essentially going to print out age, which is like 20 in our case. And then I'm going to write here method student dot hello. So essentially you could see that there is no hello method in student class, but it is here in the person class. So as student class is being inherited from the person class, it can work with the methods inside the person class. So we write here student dot hello, and it's going to output hello, my name is Chris and I am 20 years old. And now let's call the method from here in the student class. All right, so I'll call student dot study. I'll pass the argument because it needs the argument. I'll pass like math. Okay, so now let's just save it. Let's just go ahead, and before that I want to explain to you guys. So as I've told you earlier, we have two classes. Now this is the object in which we have added the values, the attributes, okay, the inputs you could say, and then we are printing the age of the student. And here we're calling the method, which is here, and then we're calling the study method here. Okay, both methods have some specific things in it, like print statements, which are going to be executed, and the data is going to be displayed. So I'll just save it. I just go ahead and if I run the script here, you can see that first it is printing out 20. And why is that? Because we are getting the attribute age right here. So then you can see it is printing out like, hello, my name is Chris and I'm 20 years old. Why is that? Because we're calling this student.hello method, and from here it is picking that up. All right. And then we're calling student.study method. Because of that, it is printing out like Chris is studying math because of this. All right, so I hope you've got the concept of inheritance. Now it is clear to you. So let's talk about encapsulation. So encapsulation is the bundling of data and methods that operate on that data within a single unit. All right, it hides, or single unit means a class. All right, it hides the internal state of an object and only exposes a limited interface for interacting with it. Okay, encapsulation can also be referred to as the privatization of the data. So privatization of the data is absolutely a must, because you want to have private data so that nobody else can use it. All right, so the example of it would be like, if you are right now you have a person class, right? So in order to understand encapsulation, let's do an example and understand it better. So let's say I'm gonna create a class as, let's call it car, and then I'm just gonna write here the constructor, which is gonna be init, and then I'm gonna have here arguments. First is gonna be self, and then I'm gonna have make, model, year. All right. So in this example, I'm gonna demonstrate the application of encapsulation. All right. So when I write here self._make equals make, so this is gonna be an encapsulated attribute. All right. So I'm gonna have here self._model equals model. This is also a encapsulated attribute. All right, this one is also going to be another encapsulated attribute. All right, and then I'm going to have here self dot underscore odometer reading, and I'm just going to give it a value 0. Okay, this one is also an encapsulated attribute. So after that, what I want to do is that I want to have a get function here. These are also called as getters. All right, so setters and getters, they are basically two concepts in object-oriented programming. If you want to know more about them, you could just simply search on Google and you'll find plenty of content to read about them. So I'm not going to get into that discussion right now. So I'll just write here get make self, and this is a getter method, so I'll just simply have to return that. So I'll return self._make. Okay, so then similar to that, I'm gonna have another getter method, which is gonna be get_model, and I'm gonna have self inside of it, and then I'm just simply returning self.model. All right, so then I'm gonna have another getter, which is gonna be get here. Okay, so I'll just write here define, which is a function, get here, and then I'm gonna have self here, and after that I'm gonna write here return self._year. Okay, so once I'm done with that, then I'm just going to write here define, and then I'm gonna write here get_odometer reading, and then I'm gonna call it self. I have return here self._odometer_reading. All right, so once I'm done with that, then I can define another method, which is gonna be, let's call it update odometer, and then I have here self comma mileage. All right, and in here I say if mileage is greater than or equals to self dot underscore odometer, and then I'm gonna write here self dot odometer underscore reading colon. Then in that case, what I want to do is I want to have here self dot odometer and underscore reading. I want to put it equals to mileage. All right. Else, what I want to do is I want to have here, hold on, I think I need to have here a colon, so that was a typo. All right, so here I'm gonna have an else block, and in this else block I want to have a print message, and I just say invalid mileage increment. So if you do not understand right now, don't worry, I'm just gonna explain everything to you in a while. So now as you can see that we have a method named as update odometer. So in this print statement I'm gonna write cannot roll back odometer. Okay, so after that what I'm gonna do is I'm gonna have another method which is gonna be called as increment underscore odometer, and this is gonna have self comma miles. All right, so I'm gonna put a colon here, and in here what I'm gonna do is I'm gonna call here if miles greater than 0 colon, and in here I'm gonna call here self dot underscore odometer underscore reading plus equals to, and I'm gonna say miles. All right, and then I'm gonna have an else block in which I'm gonna print invalid, otherwise I'm gonna print invalid increment or invalid mileage increment, you could say. All right, so now this class has been completed. So what I'm going to do is I'm going to come out of the class. So let me just go full screen here, and now I'm going to create an object. Okay, so the object is going to be something like this. I create my car object, and I basically give it attributes. So let's say I give it attributes like the company name is like Toyota or a Honda, whatever you can name it as you like. And then you are going to put a comma here, and then you write here the model, let's say Prius, and then after that you are the model name and then model year. All right, so model make is 2020. All right, so here now you're gonna have to access the encapsulated attributes using getter method. So this is what we have done. We have created an object, okay, and the reason is like we have 3 variables here: make, model, year. So we have make, model, and year. All right, so now let's go ahead and let's access the encapsulated attributes using getter method. So for that, what we're going to do is let's have a print statement here, and here we say make. All right, and then we write here, let's say comma, and then we call here my car, which is an object, and we're gonna just write here dot get make. Okay, get underscore make, the getters that we have here. Okay, this one. So what I'm gonna do is that I'm gonna simply copy paste it
for make, model, year. So what I'm gonna do is that here, instead of get make, I'm just gonna change it to get model, and here to I'm gonna change it to get underscore year. Okay, so now we have three sort of what should I say, like print statements. And then what I'm gonna do is I'm gonna print odometer reading using the print function, which is gonna be something like this. So I'm just gonna write here print, and I'm gonna write here odometer reading. All right, also need to edit that, so I'll just edit that like model, and then here. So then we have odometer reading. Here I put double quotes, and then I write here my car, which is an object, and then I write here dot get underscore odometer underscore reading. All right, so once I'm done with that, after that what I'm going to do is I'm going to update the odometer reading, okay, using the method that we had. So I'm going to use the object my car dot get, or let's say increment. I can also update it by using the update method. So I write here update underscore odometer. Let's say I give a mileage of 10,000. Okay. So next what I'm going to do is I am going to increment this odometer reading. So for that I'm going to write here my car dot increment underscore odometer. All right, and I'm going to increment it by 500. All right, so then I'm just going to print here updated odometer reading, print, I just say updated odometer reading, and then simply I'm going to call a method here named as my underscore car dot get underscore odometer underscore reading. All right, so this is a perfect example of encapsulation. All right, so here we have the constructor, and we have the objects which are private. We have set the getters here, and then we have basically these are the methods, get odometer, update odometer, and then increment odometer. Okay, so these are like three methods that we have here. I'm just gonna have to close it, and then I have created the object here, which is my car essentially. So now here, if you see, I am accessing the encapsulated attributes using getter methods. All right, so that's the beauty of encapsulation. And then basically I'm just printing out the odometer reading, whatever it is. I think it's going to be 0. I then update the odometer reading using the method, and then I increment it using the method. So let's just save it. Let's just go ahead and try to run the code. We've got the make, model, year, which is Toyota Prius 2020. Odometer reading is 0 currently, but then we have updated it like 10,500. All right, first we added the reading 10,000, then we have incremented it successfully, and now we are printing it. So in this example, the car class here, let me explain to you again so that you understand it better. This class represents a car with attributes having make, model, and year. Okay, and it also has an attribute called as odometer reading. So it has make, model, year, and it has odometer reading. These are the attributes. So the getter methods that you see here, get make, get model, get year, get odometer reading, they are provided to access the encapsulated attributes indirectly. Okay, so that makes it really powerful. And then we have public methods named as update odometer and increment odometer. All right. So these are the public methods that allow updating and incrementing the odometer reading respectively. So like when you're updating it, it keeps on enforcing the constraints on the values which are being set. Okay. So encapsulation, it basically helps hide the internal state of the car object and provides a controlled interface for interacting with it, preventing accidental modification of the object's data from outside the class. Like for example, if you want to like work with it, it's not going to give you access to make changes to the attributes of the class. All right. So encapsulation, it helps hide the internal state of the car object and provides a control interface for interacting with it. All right. Which prevents ultimately the accidental modification of the object's data from outside the class. So you could see here we have like these are the attributes that we have: Toyota, Prius, 2020, and of course this mileage that we have here. So from outside the class, these things cannot actually be directly accessed and modified. All right, so I hope this example clears the confusion about encapsulation. Now you understand what encapsulation is. So now let's discuss the final concept that we're going to discuss in object-oriented programming, that is polymorphism. All right, so polymorphism is a fundamental concept in object-oriented programming that allows objects of different classes to be treated as objects of a common superclass. And it enables a single interface to be used for objects of different types, providing flexibility and reusability of the code. All right. So now let's talk about the final concept in this video of like object-oriented programming, that is polymorphism. So polymorphism, it allows objects of different classes to be treated as objects of a common superclass. All right. It enables a single interface to be used for objects of different types, which ultimately provides flexibility and reusability in the code. All right. So if we talk about specifically in Python, polymorphism is achieved through dynamic or runtime polymorphism. Okay, so if we talk about polymorphism in Python, it is achieved through dynamic or runtime polymorphism. So polymorphism in Python is primarily demonstrated through method overriding. So let me give you an example here and let me talk about it. So let me just remove all of that. So I'm going to give you a short example so that you could understand it better. So I'm going to create a class called as animal, and I'm going to create here make sound self, and I'm going to print something in here. So print some generic sound. All right. And then after that we have like another class, let's call it dog. All right, and basically dog is an animal as well, so we're gonna do that. We're gonna inherit it, and then we have def make sound self, and here you can see that now we are overriding a method, right? So that is called polymorphism. When you are inheriting, this is only gonna inherit the class, but you don't essentially make changes within the class that is being inherited. All right, but now here you can see that we are overriding a method, and in here I'm just writing here bark. Okay, so similarly, let's say you have another class named as cat, let's say, and it is an animal. This class is being inherited from the animal class, and here you write here def make sound, and then you write here self, and then you write here print. The sound of cat would be meow. All right. So then once you have that, you are going to create instances of dog and cat. So to do that, you're gonna write here cat equals cat, and then you're gonna create an instance for dog, and this is gonna be something like this. All right. So now you're gonna call the make sound method on both objects. All right. So dog dot make underscore sound, and then cat dot make underscore sound. All right. I'm just gonna correct this. So if I save it, and first of all, I'm gonna go ahead, I'm gonna run it, and I'm gonna show you what happens. It says bark and meow. These are the two outputs. So now let me explain to you the example what has happened here. So this is the main class or superclass, which is an animal class, and it defines a method make sound. All right. And then we have the dog and cat classes, which are being inherited from the main animal class. All right. And in these both classes, what I have done is that I have overridden a method named as make sound. Okay. So here you can see that both of these classes, they are overriding this make sound method, and they are doing their own implementations. All right. When this make sound method is called on these two objects of dog and cat classes, the appropriate overridden method is invoked based on the actual type of the object at runtime. This is dynamic or runtime polymorphism in action. All right. So I hope you've got the point. Then polymorphism allows for a common interface make sound method, in this case, to be used with different types of objects, dog and cat, promoting code reusability and flexibility in Python programming. So that's it for object-oriented programming. We have covered classes, objects, attributes, methods, and we have covered inheritance, encapsulation, and polymorphism. So I hope you now understand the basics of object-oriented programming. For further clearance of your concepts, go ahead and do some of OOP examples on your own, and that's it from this topic. So now we are done with all of our topics. If we go back here, we are done with Python object-oriented programming. So this was the part 1 of the course, in which we have just discussed everything that could make you a good beginner in Python. So this course was for beginners, and the next course is gonna have a little bit advanced stuff in Python. So go ahead and practice on all these topics, because the part 2 of this course, which is gonna come up, is gonna be Python advanced learning. So until next time, see you. So if you have liked the course, please leave a comment, like this video. And if you have a question, leave that in comments. I'll make sure I answer your questions. And until next time, I'll see you with another video. Bye bye for now.